All right, you guys should be able to hear me. That looks good. All right, I'm gonna find something to talk about tonight. So let's see. I've got so many different topics here to choose from. So maybe for tonight we will go back to some of the intro stuff. We'll do some intro to cloud computing. We haven't talked about that in a while. Pull that up there. We'll talk about that a little bit. We'll talk about some general troubleshooting. I don't think we've talked about that in a while. Yeah, maybe some general troubleshooting. That'll be good. Hey, how's it going, fishermen? Cypher Enigma. You guys, we are working on the stuff that we're working on. Let's see. What other things might we want to do? What other stuff? RNX. Yep, we are just gonna be working on system. I'm just looking at my old things. Many things to talk about. What I got in virtualization? It's been a while since I looked at that. All right. You know what I haven't given in a lot. Well, we don't need to do. That'd be too Ansible-y for the night. I like Ansible, but I'm kind of Ansibled out tonight. I've done a lot of systems work the last few days. I'm kind of beat. So yeah, thanks for the affiliate anniversary thing. Let's talk about some troubleshooting. So this is gonna factor into some of the stuff that I'll be. I'm kind of going through my notes and looking at stuff that I haven't taught in a while, because I want to kind of get ready for our Linux Systems Administration course that's coming up, and I want to make sure that, you know, we're working through things. There's a big part of being like a systems administrator, systems engineer, where you just kind of have to have the hubris of like, I'm just gonna fix this thing. Like, this was designed by a person. They probably weren't that much smarter than me, and I should be able to figure it out. There's a certain hubris there, like a thinking of yourself in a way that you will be able to figure it out. So, Nick, how's it going? And Heimnall, thank you for your knowledge using these streams along with my other study out. Yeah, well, we're just talking about stuff. And then JS, you said, am I sharing my notes anywhere? Yeah, I can pull up my Discord. And typically, I'll post that here for you guys on the YouTube side as well. And yeah, I share the notes and stuff down in the Discord when I'm done. These things here, all my PowerPoints, they're all up there. All you gotta do is go look for them. Let's talk about general troubleshooting, right? Like the idea that something is not working the way that it should. I talked about this all the time. In fact, I really like that Ash talked about it last weekend when he was in. He was given the talk. Was it last weekend? I think it was last weekend. I've been so busy, I don't even know anymore. But he was talking about, hey, when we learn the most when we have to break something open and go figure out what's wrong with it, right? And I agree. You know, like, you don't know much about a vehicle until you've taken it apart and seen how it works. Like, you might be able to go turn a key in it 5,000 times, but until it breaks and you have to get it going again, maybe you haven't really spent a lot of time in there, you know. Well, anyway, so this is troubleshooting steps. This is a generic way to troubleshoot things. I learned this. The U.S. military teaches this. They teach different variations of it to different stuff, but this is one that even an infantryman could figure out. Like, there's a problem. Gun, no shoot, right? That's an infantryman's problem, right? Guns not shooting. Well, we call them rifles, but it doesn't matter. Identify the problem. There is a problem. Some system, something that cycles in some way has stopped working, right? Then we establish a theory of probable cause. Like, well, why is it not working? Well, I understand that there's 8 functions to this thing: feeding, chambering, locking, firing, unlocking, extracting, ejecting, and cocking. I should know those things because this is literally the only thing I do in my job if I'm an infantry guy. And establish a theory of probable cause. Something's busted, something's not working right. So then we test our theories to determine the cause of the problem. Maybe we restart the cycle of whatever it is that we're doing, or we try to Some people will say step back, walk back through what you were doing when it happened. Test your theories to determine the cause of the problem. This is a really hard one in troubleshooting, because a lot of times you're speaking a language here and the user is speaking some other language. You are speaking the technical language of like what the system is doing, and they're sitting there telling you that the system is funny and no worky. That's not, what I'm saying. There's some disconnect there. So you got to test your theories to determine the cause of the problem. And sometimes this is asking users. It's getting clarification. I've told you guys this before. I don't get called out nearly as much anymore as when I used to when I was on call all the time. But I don't do on-call work anymore, really. But if they need me to, I will. But when I was more junior and did a lot of on-call work, I'd get called out in the middle of the night and they'd be like, the server is down. And I'd be like, the server is down. This is terrible. And then I'd ping the server and SSH the server, and the server would not, in fact, be down. And then they'd go, well, the service on the server that we need is down. And I'm like, well, that's a different problem. It's still my fault, or still my responsibility to get it working because I'm the server guy. Everything's your responsibility if you're the server guy. But the point is, you're dealing with people who they lack the capability to have the precision that you have because they don't even know what they don't know, right? Does that kind of make sense? And that's not, understanding that and knowing that that's a fact does not make you an asshole. It does maybe inform how you should probably talk to people. I mean, if you talk to people like an asshole, you are an asshole. But I'm saying like it should inform how you kind of maneuver and discuss things with people, right? Get clarification, learn how to ask questions when you get on a call that help you to, direct what you're trying to do. So anyway, so you test your theories and determine the cause of the problem. Establish a plan of action to solve the problem and implement a solution. Sometimes this is, and solutions are in our systems administration course. This is going to be a big part of this. Hey, Isobu, how's it going? As a big part of this is we need to, sometimes solving a problem is not that night. Sometimes that night is just getting the system back running. Sometimes there are systemic problems. Now, we break this out. If you ever take ITIL, if any of you guys ever do ITIL type work, and ITIL is that's ITIL. That is a great process for managing IT networks and systems and all that kind of stuff. It's a great methodology. I have an ITIL version 3. I never went for 4. It's probably great, right? Where was I going? Establish plan of action. Yeah. So when you're establishing that, sometimes ITIL breaks it out like this. There's an incident, there's a problem, and we got to get the system back up and running. That's like having a flat tire. You got to get the car, you got to go. But if a problem is like a systemic thing, so like this is going to happen again in a few weeks when the log files fill back up. Now we have a problem that we have to go solve. The initial fix, the incident was, well, wipe those logs and then we'll get back on with our day. But that's not solving the problem forever. Does that kind of make sense? So incidents happen like overnight, and they happen in a what we call a acute fashion. They happen right now, and then problems happen chronically and cause incidents of outages and security and all these other kind of things. Because I don't know how much you guys think about this, but again, systems administration world, right? You're talking about systems administrators. They care about the uptime of the system. Engineers care about the stability and they build that in, but administrators mainly live and breathe by uptime, right? There's even an XKCD that's pretty funny about that. That he's in there killing everybody to keep his uptime up, right? But the where was I going with that? Yeah, you live and breathe as a systems administrator by your uptime, and then I forgot where I was going with that. I lost the thread, guys. I lost it. ITIL, Agile, these things, even Scrum, sprints fall into that for me. People make errors and have a written down process how to interact with stakeholders and how to communicate properly. Yeah, so look, any of the structure type things, I think they need to be kind of guide rails. I don't think any of those things need to be like laws. In fact, the four rules of agility kind of give you free reign to do things outside of just, tapping a contract and going, you will do this, you will do this. I was working with a customer today and yesterday, and not to get too much into what was happening before I had gotten on the contract, and before, well, shoot, even before my company had gotten on the contract, there had been a misunderstanding in something that was going to happen with the systems. And that misunderstanding cascaded forward till like a couple weeks ago when they said, hey, we need this thing fixed. Well, we could sit around and we could argue and point fingers and tap on contracts and stuff, or like my company could send me out, and obviously this rolls up to the actual company that made the mistake. My company's just a subcontractor to it. And I went out and the last 2 days I fixed something that was systemic to the start of the project. Now you might say, well, who pays for that? Well, in contracting, right, there's two ways that contracting works. I don't know if any of you guys have done any contract theory or any of those things, or actual contracting. There's fixed price and then there's cost plus as like two general buckets, right? Fixed price are where like you want a wall built and I say, well, I could build you a wall for $1,000. And then if I can't build you a wall for $1,000, I eat it. I eat the extra money that it costs to build that wall or whatever. But that $1,000 that I tell you, you don't care how I get it. If that's 800 in bricks and 200 in labor or whatever, you don't care, right? Because I've given you a fixed price. Now a cost plus is I'll come out and I'll start this wall for you for $500, but it's going to be that and then all the work it takes me. And then you would probably rightly say, well, how often, how much does it normally take for you to build a wall? And I would say, well, I normally build a wall of, 1,500, 2,500. Now, here's the thing. Some of you are probably thinking, well, Scott, hold on. Everything you just said is contingent with how much you know, and that's true. Fixed price contracts only work if you know exactly what the scope of the work is, and you know exactly how well you can do that work. A cost plus is where it's like, well, I kind of want a wall and it kind of meanders this and this and this. But if you tell me I want a wall and it's 48 feet by 48 feet by 48 feet by 48 feet and it's just going to be this square, I could absolutely tell you exactly what that cost me to build. I've never even built a wall before, but I can go price that right now while you watch, right? That's easy stuff. That's like easy contracting stuff. I mean, I can go build a little Excel spreadsheet and it would do all this stuff for me. We can make the wall bigger. We could do whatever. But the fixed price contracting is that. Anyways, I don't even know where I got off on that because we're talking technology stuff, not even. But look, engineers don't have to be dummies in the business. That's actually kind of like a misnomer. Like it's kind of thought of like as you start out your career. And I joke around a lot about this, like just throw me in a basement and leave me alone. I don't need to know what else is going on. But the more you kind of add value to an organization, the more you do some of these other things that we talk about to like make yourself more valuable, where you know things and you know how to troubleshoot things. Those are your two things you do as an engineer. You know things and you troubleshoot things. Those are the only two tasks of an engineer. So this is one of the two tasks right here. All right. Anyway, so we established a plan to solve and implement the solution. When we're doing that, when we're done, we verify full functionality and if applicable, implement preventative measures. Sure. But if the full functionality is not there, we have to step back to here. By the way, I was being grossly oversimplified. It was an oversimplification to say fixed and cost plus. There are all types of other contracting in between there, but I was saying it like left and right. Like you've got this over here and this over here, and this is how they interact, just so you guys know. Loophole, that is probably one of the most accurate types of ways that I could think of it. Just implement and remove everybody else's stuff. Yeah. Sir, caffeine reminds me of pen testing. Yeah. So then we verify full function. This is actually, so it's funny you say that, Sir Caffeine. This right here is very much the whole purpose of a purple team. So when people talk about red teaming offense, which you guys know I've run teams like that, and then blue team, which I've never run blue teams, but I've been like an input to blue teams often. Well, a lot of times they don't like each other very much because the red team gets to do all the cool stuff and then the blue team has to fix everything, right? But the goal of a purple team is basically this right here. It's to rapidly move through the fix and remediation process. And by the way, I don't know if they still do it. Let's see if Purple Hats still exist. Purplehats.org. Do they still exist? Purple Hats was this Attack IQ thing. If you guys don't know who Attack IQ... Oh, let's check on Ranger. Oh, look at him. Look at Ranger Dog. Anyways, attack IQ is when is Purple Hats this year? They've got last year up, so you can go watch it. So that's all done. But I don't know, I don't know if they're doing it again this year. But it was just about getting there. Loophole, I wear glasses or contacts. Typically, if I wrestled that morning, whether or not I'm wearing my contacts or not. So if I'm wearing my contacts, that means I went and wrestled and worked out this morning. Yeah. So Purple Hats is the idea that you're dealing somewhere between your red and your blue teaming, right? And then there's all kinds of theory on all that kind of crap. And actually, there's a really good course. If you guys ever get involved with ISC Squared, which is the organization that does CISSP and CCSP and that kind of stuff, if you ever do that, right, one of the benefits that nobody really talks about is there's these courses that are free inside of the thing. And they're courses that would probably cost a couple grand to take, but they're all free. And like I took the purple teaming one. It was really good. There's a whole bunch of stuff like that as well. I actually do freestyle and Greco-Roman, but I mostly do Brazilian Jiu-Jitsu as far as like what you would like. If you saw me in the morning wrestling, it's mostly in a gi, so I'll do no gi as well. But I have worn contacts since I was in 8th grade, but I don't always wear them. So a lot of times you guys see me in my glasses. Also, sometimes I shave and sometimes I get my hair cut too, but I haven't done any of that stuff. So, yeah, that attack IQ is pretty good. All of these organizations are just using methods that are out there that you could find. Like Attack IQ does some really cool stuff, but you could build your own program, but it's hard to build your own program, guys. To keep automation of like persistent threats against your infrastructure, that costs a lot of freaking money. It costs a lot of money to do that stuff. So a lot of people like to outsource that. In fact, people like to outsource pen testing and all that kind of stuff as well. Yeah, I will twist people in the pretzel. Sometimes we call Brazilian Jiu-Jitsu, sometimes we call that just folding laundry with people still in it. That's actually something that we say in the sport sometimes. So, all right. And then when you're done with everything, you document your findings, actions, and outcomes. Now, this step, I feel like this step's redundant because you should be documenting throughout. Like you should have, I mean, look, I'm not going to tell you guys how to handle things, but I think that engineers should have a notebook. And you say, well, why would you have a notebook when you also have like 30 note tools that you keep open? Well, because sometimes I need to write something down that doesn't belong in the system or doesn't really matter to the system. Like I'll be talking to the boss or something. I'll be like, hey, do this or whatever. I have so many expensive hobbies, Sir Caffeine. Yeah. Good notes are important. And then I think you should have a good note-taking system as well as you go. So like when I do things, when I have notes in here, and actually I'm looking right now, I have things I have to do. Gosh, I got so much stuff to do, guys. I shouldn't even be streaming. It's just that I can't work anymore. I've already worked like 10 or 12 hours. I don't even know how many hours I've worked today. It's too many. So I figured I'd just come on here and hang out. And then I saw it was my stream anniversary, and I was like, oh, that's kind of cool. So, yeah. I think there's, Sir Caffeine, there's been a lot of studies, too, about, like, writing things down and how much that helps your memory. Because now you're thinking about it, you're writing it, you're seeing it as you write it, and it kind of helps you to kind of distill things down. Well, anyway, so let's look at these troubleshooting steps, right? You identify a problem, you establish a theory, you test your theories, you then establish a plan of action. You were either right or you weren't, and then you loop here. Well, let's go look at what it looks like here. So this is another way to do it. And this one really only splits out 4 and 5 from the last one. I did it myself. I missed something probably. Okay. So identify a problem and its symptoms. Sometimes you can't tell what the problem is because you don't have a good enough amount of, I'm checking my little screen here. Sometimes you don't have enough information. So all you can do is kind of gather around it and look for little things around it. And then you should be able to kind of etch out the best idea, and then establish a theory of probable cause from there. So, Some service is down. You go and you look, and well, 3 of the 7 servers in the load balancer are, behind the load balancer down, and you're like, there wasn't any patching tonight. What happened? Then, you go and you maybe dig in a little bit and you see, well, these 3 machines that are down behind the, maybe the 7 that should have been behind the load balancer, those 3 are down, but they were given a halt command. And you go, why were they given a halt? So if they were given a halt command, that means you see that in a last output, right? So you go to, I don't even have my Linux up right now because I just got home before I started streaming. I was out in a facility all day. I'll pull it up real quick. Hold on. So let's go with my jump box, right? My home lab jump box here. I'll show you guys what I mean because it's important. So screen -ls to see that this is my streaming one, screen -r, and then that right there to connect. And then now I'm back into my normal screen session that I use when I stream with you guys, right? And we were building out the Prolog lab the other day, and we were hitting a bunch of the boxes and stuff, right? Anyway, so let's get out of here. We were messing with all the Rocky boxes to get them ready for our Linux Systems Administration course this weekend. So let me think here. What was I going to show you guys? Establish theory of probable cause. I was going to show you guys something. Somebody help me out here. I got lost. You misspelled probable. Ha! That is 100% accurate. That is funny. I need to have a reward system for you. I don't know if you're in my Discord, but Yuzochi, if you identify yourself to me, I will give you some kind of award for that. That was funny. I have been looking at the slide deck forever, and I didn't even realize I had that like that. Okay, what was I talking about, though? I forget what I was talking about. I was going to show you guys something in here. Had something to do with the so in here, if you see who's logged in and what different systems have jumped into this system before, right? And as these different people connect and different things that have gotten into the system over the time, right? And where they've come from and all that kind of stuff, you can see if there was a halt given. And let's say there was a halt given on 3 of your machines. And you go, okay, well, that doesn't make any sense. Like, none of the admins were on because we bounce when we're off. We're not admins and engineers. We get out of there, right? We don't stick around and cause problems for ourselves. So then you come to find out, well, normally this weekend is a patching weekend, but we're not patching this weekend because we backed off for, some vulnerability or some other thing. There's all kinds of reasons. Sometimes you don't patch on a normal weekend that you would patch because it's at the end of the month and it's in like there's like a 5-day freeze window for some organizations where they don't spend any money or they don't do anything right at the end. Identify the problem and its symptoms. I'm pretty sure it owns the symptoms. I think that would be interesting. But check it out. So what was I saying? The hosts. Yeah. So you can see that somebody restarted the service or whatever, right? And if somebody restarts a service, then or they boot the box, then now you got to go figure out, well, who had the permissions to do that? And then you come to find out, well, somebody messed up in the somebody maybe in your bridge team or something. They had permissions in Ansible to go kick that stuff off, but they didn't realize that it wasn't patching weekend, or they didn't get a memo or something. And that's human error. But that's also a system error because the system shouldn't have allowed them to do that, but they have the permissions all the time. Well, maybe we need to make the permissions more granular so they only have the permissions in the time window that can happen. Well, that wouldn't have protected us. But then also if like a trigger or something like that has been put on there. So there's like all these things that can happen. Does that kind of make sense? But you've got to go figure this out. You got to go start digging into these things, right? So test your theory to determine the cause. establish a plan for resolving the problem, and then remember I said 4 and 5 are broken out in this one. Implement the solution, verify functionality, and implement preventative measures, and then document findings, actions, and outcomes. All right. So these are the things that we do in our troubleshooting methodology, right? So then this is what that kind of looks like, right? This is the view of that, right? You start over here, you gather information, you identify symptoms, you question the obvious, you move through the OSI model, maybe. That could be part of your methodology. We'll talk about that here in a minute. Test your guess and spin. Did you find out what you needed to? Did you need to escalate and stop? Send this up to somebody with more power? It could be that you find that, and this happened to me a few years ago. People... The longer you are, doing this engineering, I was the platform engineering team lead for about 5,000 servers at AAA. I was their lead, right? And somebody came to me and said, Scott fixes everything. Scott fixed this. It's on one of your servers. So I went to the server, and the problem where I had to give up was when it was asking me for an API key into our AWS. When that happened, I could no longer move forward because I didn't have control of the AWS thing. Does that kind of make sense? I took it as far as I could go. I troubleshot as far as I could, and then I had to give up because I either had to get the permissions to do that, or I had to hand it off to the person who was responsible for that and did have that key and get that to go. It was something to do with one of the keys had I don't know, something, maybe it had got rotated for like some new security policy. Typically, a lot of times with keys, you have to rotate them every so many days or every so many uses across the network. Even if they're TLS, even if they're at a certain hash level, you still have to do that. All right. So we have that. All right, anyways, so this one comes from Microsoft. We react, research, engage, adjust, configure, and take note. I think this one's really easy for people to remember, so I think that this one's a pretty good one. I probably need to redo that one of these days because it kind of looks like I blew it up and it's not so easy. But research is check the internal documentation, look at internet websites. Nowadays it would be Ask Copilot or whatever type of tool you're going to use. Engage, ask for problem description, ask clarifying questions. That's that idea that, like, I'm telling you, you're speaking two different languages. You're going to be talking about something from a technical, like, under the hood background, and the other people that are going to send you alerts and messages and tickets or emails or whatever are not going to be asking you things in a way that you're used to looking at. You're going to be looking at it going, the hell are they talking about? Are they talking about a coffee maker? Like, the hell do they mean? Like, and then come to find out it's some other tool that somebody put on some of your servers and you didn't have anything to do with it, right? Like, so this happens all the time. Yeah, ICQ, there's times all the time when no one knows anything about system. That's actually like the premise of early labs that I've built are you're going to a system that nobody ever documented, because this is what we got to do. We got to like go and figure out what's going on in the system and all that stuff. Then once we've engaged, we change settings, reinstall hardware, reinstall drives. That's our adjust, whatever we're doing there. And then we go to configure and we ensure that our standards are enforced, which means to put configuration protections in place. And then it says update standards if needed. If you find a gap, like I just said earlier, the bridge team could do the patching updates whenever they wanted. They always had those permissions. Well, we could have limited them down to just that weekend, but that weekend wouldn't have saved us because we didn't get approval. So they did it on the weekend, and that was the problem. And then, but normally it wouldn't be, because, like, let's say the last 12 months it had always happened. So this person assumed when I come in on this night, I'm just going to do it. Guys, this you might think this doesn't happen, but I assure you it happens. It happens in the best, most organized places around. I guarantee that stuff. If I could get the guys, most of the guys that I know that are in like AWS and some of these other places, they have like NDAs and they can't talk about it. But they could probably tell you about all kinds of stupid stuff like that that's happened. So yeah, and the alpaca said documentation's been my job for last year. 100%. That's, I mean, it's huge. I'm building out training right now for a system we're building, and basically that just means like write all the documentation for a bunch of stuff. Mr. Poolshot, thanks for the the happy affiliate, and then Quartz One. Thank you for that. I appreciate it. The subscription.
Happy
hopefully,
affiliate anniversary.
The text to speech I have is directly through Twitch, and it's like the worst thing ever. I should just write one for my own. All right. So you've got problem resolution. Problem in this sense is exactly wrong from ITIL. If you use problem like this in ITIL, you're wrong. ITIL is, their problem is what we call an incident over there, right? So this is why I tell you guys, like, I don't want you to learn all of these. I want you to learn the one that's going to work for you when you need it, like in the middle of the night, right? When you start a job, ask questions, and no one knows, document. Yep. The alpaca, that's actually, you know what? If you want, and this is coming from a guy, I've told you guys before, like, I'm not being a chat about this. I've given over 350 technical interviews. I'm started keeping track a while ago, like just how many interviews I've given to people, because I do them all the time. And like I'm the one that's the technical interviewer. And one of the things that I would always ask, if and this is, I like when people ask me this, is they ask, like, how good's the documentation around here? Because I guarantee you every one of those interviewers is going to look around and chuckle. If you're on like a panel interview, or even if it's just one-on-one, people are going to 100% tell you, like, that's what we need. And if you find that, like, you're really good, I spent a good part of my career being really, really good with MediaWiki. I still think I can mark down MediaWiki pretty well, but I think that like being good at that, and then hearing, like, I've heard like 10 plus years later, hey, we still use some of your documentation in some of these systems. Actually, I take that back. Just the other day when Robbie Reed came to talk to you guys, he was saying that some of the stuff that I implemented back, I left in 2013 from Lockheed, so that was over 11 years ago. And now he's a contractor. Well, he's a director of engineering, but he's on the same contract, and he still uses some of the stuff that I built and some of the documentation too. So yeah. The alpaca. This is all you get for me. This is like, I don't document anything else. Well, I do for work, but I'm saying, like, for me. All right, so this is what we do, guys. Right? We react or whatever. But this next one's like been pretty clutch for me. Being able to step through the OSI model. This one I noted this, highly effective in my career. This is like one that's like worked very well for me. I came from a networking background. I understand how these pieces work together well. We talked about this before, but let me show you like an example of this, right? Like, let's say that I want to ping a company. I'll show you guys something that you guys might not know. And some of you might know, but some of you might not. If you ping yahoo.com, it'll respond, right? It does. And if you ping google.com, they'll respond, right? With whatever's local and closest to you. And we've done all the DNS. We've took all this stuff apart. There's a lot of stuff happening under the hood, but your system is getting an IP address, and then it's using that IP address to go talk to those through, this is the ping, which is the packet internetworking groper that uses ICMP, echo requests and replies under the hood to talk and figure out how fast things are, right? Sure. But did you know this? If you start to do weird shit to your packets, which you can do right here with ping, Yahoo will still respond, and some companies will. Google will not. Watch this. So I'm gonna ping Google, and I'm gonna make the packet. So let's say we'll do a count of one. So we're just gonna send one, and the size we're gonna make it like 1700. And Google's like, but Yahoo still will. Yahoo will still respond. They don't give a crap. You play around on their network all they care, or they don't care. So there's a whole bunch of reasons to know how to make the size of a packet bigger or smaller, and we've done that, and we're going to do it in the systems administration course that's coming up. I've shown you guys this a little bit, but your maximum transmission unit is so important to know, because we can set those packets as they come down. Packets are here, and as they're getting set down into layer 2, which has a maximum transmission unit size of 1500, we can tell that layer not to cut these up. And if we do that, watch what happens on our network. So I can ping Yahoo like this, right, at 1700, or I can ping them with nothing, right? Just a regular size nothing. I think the packet's like nothing size. Check this out. But then I can say with a dash capital M, do set the don't fragment bit. This is super weird. And now it'll say, can't send it. You told me it's this long, but 1500 bytes is right here, and I was going to have to cut it in half to send it, but now I can't send it on my network, right? And knowing, we're not going to get in right now how and why that matters so much, but my point is, understanding that problem right there can help you deconflict a whole bunch of ways that packets traverse your network, especially if you have like storage devices out there. Let's say you have a NAS storage, that's network attached storage, so you're going across your network shared with data and other things, right? And then, yeah, jumbo frames, huge. I've had to prove before with not security teams, with my networking team, that the jumbo frames were not set the entire path. And I did that through that process. I walked it and I said, we break right here. I can get to this device and then I can go no further. And I proved it to them, right? And I've had to do that before. But that's because I understood what was happening here. And I understood how to prove that that's like that. And, you know, you guys have these commands and stuff, right? They're super simple commands. But while they're super simple commands, it's like that old, you guys heard the old engineer that, you know, the factory shuts down and the chief information or the chief financial officer's like, whatever it costs, get somebody in here to fix it. So they called an old engineer that retired, and he comes in and he's got his little hammer. His hammer's like this big. His hammer's like, here's my little prop. His hammer's like this big, and he walks over and he looks around and then he goes 1, 2, 3. He just taps 3 times. You guys have all heard this story, right? If you haven't heard this story, I love this story. So the engineer taps 3 times and everything in the factory turns back on and starts working. So the CFO is looking through the bills at the end of the month, and he looks at the bill for that engineer, and it's $75,000.75. And he's like, what the hell? So he calls and he says, get this guy on the phone, right? And he's talking to the engineer, and he says, look, I get the $70,000 or $75,000. We were losing that every hour that the factory was down. I get that. What's the 75 cents for? And the guy goes, well, I'm gonna be honest, I had my little hammer with me, and it was 25 cents every time I tapped on that pipe. It was 25 cents. And he's like, okay, that's okay. So what was the 75,000 for? And he goes, to know where to tap. And that's like the crux of all engineering, is like, you have to understand how these systems work. Again, you don't have to go be an expert in networking, but you do need to understand that your Linux system does not exist in a vacuum. It's like I tell security engineers all the time, like the system exists to do a thing. It doesn't exist to be secure. So we have to find a balance. We always have to find a balance. Like, security will slow down a system to a screeching halt, understandably. Like, I understand it. They want it to be secure. But the system also has to do things, right? Yeah, you can still make mistakes. There's always mistakes to be made, right? But anyways, I have a primer on this. I'm not going to talk about this, but I've told you guys this before, and I know one of you guys one of these days is going to convince me to actually do it on stream. But I can talk to these. I can talk to these for 20 hours straight with no notes. No doubt in my mind, and without going over the same thing, without whatever. I could just freestyle off the top of my head for 20 hours on this. And you guys might not believe me, but I guarantee you, I mean, you know, no notes except for just, you know, the slide deck or whatever. But yeah, easily. I've been teaching it for 16 years. I've been doing it for 22 years. It's like, this is like the bread and butter for me of all the other types of engineering I do. It's like, it's a base of like network engineering. So, okay. So then this is another one. This one's like knowing hardware and software, like common failures is a big part of it. So some of you guys, you're going to go start your career in a data center. You're going to start your career in a knock. My wife is still a help desk person for the school district that we met at when I got out of the Army. Wait, what happened to ICQ? We had such an overload of firewalls that it was basic. Firewalls would drop packages from anything else that fails, and people shedded tears over me. Well, I mean, I'm sure it depends on how you set it to them, ICQ. All right, so this right here, this is like, okay, so you're in a data center, and you've got the same exact Dell equipment or, I don't know, whatever company you have as your provider. And you just have rows and rows of disks and rows of systems, and they're all in, the properly designed things. And as you walk up and down those rows, for you people with normal color vision, you will notice all the different types of lights. And all green lights are good, and all, a couple of yellow lights here or there are bad. Now, thankfully for people that are colorblind, and if you're colorblind, please allow me to tell you that you'll probably be fine in a data center, because one of the tricks is that the lights blink differently when they're yellow or red. So it doesn't really matter if that little tiny LED is green or a slightly different shade of green that starts to fall into the realm of yellow. It doesn't really fucking matter because they're blinking differently. So the point is, you can look up and down the row, and typically, as long as you're, I don't know, paying attention, figure stuff out. But they're going to be the same types of failures. Guys, we talked about this, and again, this is one of these things that I guess this does fall into this, so we can go talk about it a little bit. ICQ, you've probably heard, I know you're joking about that on the one-on-one session, but you've probably heard me say this before, and I will say this, this will be true forever. This is like the least Chad thing I can think to say about this, is that if I can do something publicly like this or down in the Discord, I will give it away for free as much as you guys want. If I have to do something privately, if it's like for your business or for something like that, I have to charge you, because otherwise my wife will kill you. Well, you can pay me lunch too. That's actually fair. But like, I can do that stuff. But ICQ, I can tell you for sure, I have at least 2.5 hours up on YouTube about it, and then I've done like a lot of these like little like ones where we just talk through it as a primer. We'll get into it in the Linux systems administration. We will get into it because we have to. We have to know our networking. We have to be able to talk to other devices and ping and move data around. This is all part of all this stuff. So, yeah. Please do not throw sausage piece away. Please do not, man. So there's a thing every. You know how like a guy who runs like a guitar shop is never. He's gonna have a sign like in Wayne's World that says "No Stairway to Heaven," right? Because that's like every guitar shop ever is "No Stairway to Heaven." Well, I'm kind of the same way with those, because as a college professor, literally every class, every quarter, one of the first questions in the discussion is go for the new students. Network 191 does this. God, I fucking hate. I don't hate teaching the class. I hate this one thing. There's always this discussion post that's like, go find all the acronyms, and they're always the same acronyms. But sometimes students will come up with like S&M stuff, and it is not appropriate for school. But it's like there are some really crazy names and things that people have done with that. All people seem to need data processing, right? However you want to do that. Please do not throw sausage piece away. Anyway, so my point is, I'm like that. Like, I don't even want to hear them anymore. I've heard so many of those. Learned quite a bit about networking when I wrote the corporate MSN. Yeah, MSN monitoring tool. Wrote the sniffer without libcac. Learned how to do DNS stuff. Nice. Or no libpcap. Okay. That's actually pretty good. Yeah. And that sounds like you like doing the software side of things, JW, because I'll tell you guys, I do all my scripts, and if it has to go more than about like 5 functions, I'm like, ugh, I don't want to do this anymore. I feel like, I don't know how many of you like, I always bring up, where's he at? I always bring up, nope, not this guy. I always bring up this guy, right? Rick and Morty, right? I always bring these guys up. But, the thing I bring up, the thing I'm talking about here is, did you guys ever see the episode where Grandpa Rick is removing curses? He's removing curses from cursed items so that people can have all the benefits, but they don't have any of the curses. Most software, a lot of AWS since 2015, 2016. Nice. Nice. We have, JW, we have a lot of AWS people around. I have a fair amount of AWS experience, but anyways, no, what was I thinking? Anyways, he's running this company, and people start coming and asking him stuff, and he goes, I just don't, and he just burns the whole place down, and that's like kind of how I feel sometimes with some of this stuff. Anyways, I don't even know where I was going with that, but my point is, you're going to have these same types of problems, and when you work in big data centers with the exact same type of systems, you do that. Yeah, JW, we have a guy in our Discord who works for him, and he's got 7 or 8 now. I think he's up to 7 of their certs. So yeah, he's really, and he works for AWS. One of our guys does. So he streams too. I don't want to out him, but he'll tell you guys when he's around. So all right. So you have these errors, you have these things, but again, they become patterns for things that, and then if I show you guys this sometimes. Hold on, let me pull this up here. I've shown you guys this before. This is a different drawing. Don't worry about this drawing. Later. Let me open recent Linux Systems Administration. Hold on. Some of these are going to go into the Linux Systems Administration talk too. Where I'm going with that is this idea here of like sysadmins tend to start over here, and they do keep the lights on, and they do knock and like all that kind of stuff. And that, yeah, it's Fisherman. Yeah, I didn't even know you were here, Fisherman. You see, it's my stream reversary that I'm very important. I'm just kidding, but optimize, do this better. So what I'm saying is you're doing whatever you're doing. But are you, and you're just walking up and down these racks, and you've got your earplugs in, and you're checking stuff. But are you thinking about how to make this process better? And are you finding that, there's a certain piece of information that always needs to be there? Maybe labels need to be done better, and you're improving the process, right? So if you start optimizing stuff, I think that's one of the best ways. If you say, well, I want to move up in the company, or let's say you want to just learn how to do something, and then you want to go do it on your own, and you want to do it privately. I can tell you that understanding how to optimize things and make data visible and make errors more obvious and solve errors faster are going to be effective for you in whatever you want to do, right? Like if you want to be better as an engineer, or if you want to make more money with a company or on your own, understanding how to optimize things is a big part of that. So that means as you're operating systems, you're thinking about how to make it better. Well, one of the things we do, and I've shown you guys, I've given you guys all the tools out there in our Discord. There are ways, if you say, Scott, I want to be an engineer that makes things better. There are a whole bunch of types of practice around that right here. Where is this? Beginner start here. So there are 2 things, and you don't have to go to college for them. Total quality management is something you learn as typically like in a bachelor's for business or like a master's program. But these concepts right here, so total quality management and also Six Sigma, they're business concepts, but they're about improving processes. So as an engineer, especially if you like math, like if you like arithmetic and stats and stuff, like quick things that you can do and kind of play with a little bit and know. These are 2 of the best certs to start with in the industry, because maybe you find that you want to improve processes. And I don't care I don't care if you're playing baseball. I don't care if you're like herding cats. I don't care if I said herding, not hurting. What? I said herding. Oh my God. And this was the day I got kicked off of Twitch, right? I said herd, like a herd of animals, herding, like moving them around. Oh God. Clip it and ship it. Yeah, I'm done, Quartz. Stick a fork in me. So what I'm saying is like herding cats, like moving cats from place to place. Yeah, well, if you think about it, how would you herd cats? They're not a herd animal. They run around like crazy. So the concept of herding cats is insane. Cats would go everywhere. So So, you know, and by the way, much like I tell you guys, things I say aren't prescriptive. What I mean by that is I can't tell you do this thing, and do this thing as an equation, and you will have a $200,000 a year job. I can't do that for you. I can tell you you should do these things to move yourself and position yourself better to get into those roles. Sure. Where I'm going with that is I'm not telling you to go do Six Sigma and then implement Six Sigma at, like, you know, some job that probably, you know, doesn't care. You know, some small IT company probably doesn't care about full Six Sigma methodology. But there are principles from that are really good that you should take from it, like measuring the amount of failures across a certain amount of things. And you say, what would be indicative of failure? I'm glad you asked. Now we start to talk about key performance indicators. And you say, well, key performance indicators are terrible. My manager's always just telling me that we're missing the mark on them. Okay, sure, yeah. They've probably set a bar too high or something like that, or they started a process and they never fixed it. You've got to tune these things. But the point is, if you're not going to measure something, you will never improve it. That is a simple fact of life. That is, look, Arnold said it. Arnold said it as a bodybuilder. If you want to improve something, Peter Drucker said it. If it can be measured, it can be improved. I don't know. There's a whole bunch of them. I got a whole bunch of quotes like that, right? I find that I'm trying to right size my ideas to the firm I just joined in. It's been tough. Yeah, Cypher. Sometimes it's some people have to just be shown, like, you just have to do stuff. And I've found that a lot as as an engineer. Like, sometimes I just build things and then I show it to people later and they're like, oh, that's really cool that works. And I'm like, yeah, I had to build it so people would stop telling me it couldn't be done. I've had to do that many times in my career because, and I don't know, some of you guys have probably been like this. There are engineers who will bike shed. Bike shed is a technical term in engineering whereby somebody doesn't want to either do work or be exposed for not knowing how to do something. So they talk about bullshit that's unrelated to anything. And bike shedders are so good at keeping people talking about the bike shed. Yeah, so what a bike shed is it's opposite of, the deal is like this. We have we're building a nuclear power plant for $4 billion. But somebody wants to talk about the color of the bike shed out front. The bike shed's 15 grand. We're going to set up a bike shed so people can ride their bikes to it. Who fucking cares, right? Like, why are we talking about the bike shed? We're talking about building a nuclear power plant. Does that kind of make sense? That's actually a concept in engineering. People love, and the guys that I know that have been very good bike shedders, I've known some good bike shedders, and I genuinely like a lot of engineers I've worked with, and I genuinely get along with almost all the engineers I work with because I'm pretty, like, I'm always ready to explode, but I'm pretty calm as far as that goes, right? And I don't, people doing shit like that in meetings doesn't bug me because I don't want to be in the meetings anyways. But the point is, where was I going? I don't know. You guys got me off on some tangent. But anyway, so we were talking about that. So this one right here requires a lot of knowledge, but not about the individual system. So this one right here is like a doctor. This is how doctors treat things. They understand the thing, the person who's coming to sit before them. They understand the system, right? They don't know you, though. They don't know you. You go into a new doctor for the first time. They don't know you at all. But they know how to look at the systems and how they should work. Then they identify the most likely cause by what's not doing the thing it should. And then they treat it with a solution. So my father-in-law, right? So I'll tell you guys a little story here. I think he'd be okay with me telling you guys. My father-in-law that's so my wife's dad, if you guys don't know. I'm sure most of you know what a father-in-law is. He had a back surgery like 4 months ago. And then he was like, well, I want to go back to Africa. And he's, mid-70s. He's fine. But they were like, well, maybe you should maybe wait another month or two and then go over. Well, he went, right? He went to Africa. He wanted to walk around and see. I don't know what he was doing there. He was just seeing things, right? He collects a lot of, like, really cool stones and rocks and stuff. But anyways, he goes over there. And he gets a I don't even know what to call this thing. I think it's like a, I'd have to look it up on the phone, but it's like a hematoma in his leg or something. And his leg swells up like this big around. It's like a basketball. And he's not a big guy. He's real skinny. So they have to drain it over there, and they have to do all this stuff. And then they're like, well, now we're gonna have to like ship you up to like Germany so you can get some more treatment before you come back. He's doing a lot better now, but this has been going on for like a few weeks. And where I'm going with that is like none of those doctors over there knew him. He had never been to any of those doctors before. And like the idea was they looked at the symptoms and they go, well, your leg shouldn't be that big. So why is your leg that big? Oh, you're forming these little tiny blood clots and it's backing stuff up. And this is pretty bad. This can be real bad if it starts breaking loose and stuff. So we're going to go ahead and put you on some blood thinners of, I don't know exactly what they did. But the point is they looked at what should have been happening and then they fixed it. And then I think they had to like cut it and then they like stapled it shut. And it was really funny because he sent us a picture. He's like, do you guys want to see the pictures of this stapled shut wound? And of course we were all, I'm a guy, so I'm like, of course. And everybody else is like, oh, okay, sure. And then he shows this staple. And I said, God, that looks like when I used to staple my homework in 3rd grade. This doctor looks like he just stapled down the fucking page. Like he just stapled down his thigh, like. It was like the worst staple job I could. If you showed me a picture of bad stapling, I guarantee you what they did was worse. It was. I didn't even think about that till right now, but that was so funny. And I sent that to him too. Like I sent in this big family group chat. There's like 30 of us. I was like, that looks like when I used to staple. He's fine. He's gonna be fine. He's gonna come back and be fine. But anyway, so but the point of this is to say this requires no expertise in your particular system. This requires expertise in how systems work. Does that make sense? This type of troubleshooting, but it requires expertise. So this is an expertise-based one. Look, back here, let me break something down that I haven't. These work everywhere. These two. This is just visualizing this one. This works everywhere as well. This is a generic idea for how we do it. Then I get more specific. I need you to know the OSI model some. I need you to understand the system a little bit. Then I say, I need you to understand that particular system that you're dealing with, right? Then I back away and I say, I don't need you to understand that system. I need you to know exactly how systems work. Like, it's one of the reasons it's so important when I talk to Linux engineers and I'm gonna hire them, or I don't hire guys. By the way, I don't hire anybody. I give recommendations to managers that ask me to do interviews for them, and I do that based on my objective template that I've shown you guys. And where was I going with that? I'll just ask like, hey, explain to me the boot process of Linux. That's a pretty open-ended question, guys. Some people start. Did I say California? I don't remember saying California. Anyways, some people will start at the hardware. The hardware, you push a button, the physical machine turns on. There's power to the motherboard because a switch was clicked so that power would go to the motherboard. The motherboard performs a power on self-test of all onboard and peripheral components. It walks its system bus. It does all these things. If anything doesn't work, it gives a beep code, typically. And then if you have certain types of motherboards, they will also have all kinds of logs that you can go pull off, right? Just you got to ask what a browser does when you type URL and hit enter. Yeah, you know what? It's funny. It does a surprisingly large amount of things. It does, like, people don't maybe even think about this. But where's the hacker button at? Is that F12? What's the hacker button right here, right? This is all the stuff that's happening in just this right here, right? So, people call it the hacker button because you're doing whatever dumb shit you're doing, and this is what's going on over here, and you can then go watch. You can go over here and you can hover over things, and it'll tell you over here. Oh, I closed the console. It'll tell you over here what's happening or what part of the component each one of these things might be, right? And then there's there's just all kinds of things. Man, I probably got even other things open over here that you know. Anyways, but the point is, there's all kinds of things happening. But even, yeah, as JW01's talking about, even if you only knew that the browser, so look, some people are going to say, well, the browser takes your, you know, common name, your DNS name that you do, goes and does a DNS query. I don't know exactly how that works, but it does a DNS query, and then it gets back an IP address and takes that IP address and it goes out to the location, and then that location sends you back whatever. That's the basics of what it does. We could prove that out. We could watch that in Wireshark. But then you could go a little deeper and you go, well, if we're doing TL, or if we're hitting HTTPS, my system is going to see if it has a certificate that for that site that we're going to. If it doesn't, it's going to see if one of the public trusts or trusts that it has programmed into it has a certificate for that site. And if it doesn't, it's going to go ahead and send me back a message that says that this isn't a trustworthy site. Do you want to continue? But if it does have a public version of a certificate for that, it'll download it and use that to send a message. And then that message will be opened by only the person who could have the private version of that, right? So that third party has now introduced us to each other. And however far you guys want to take that, however far you want to dig into that, that all I did was ask you, how does this work? And as JW pointed out, all they did was ask him how a browser works. So I ask, how does a Linux system boot? And then, you know, some people will get into, well, okay, once that's all done, once the system's walked its bus, it goes to the bootable devices in order, typically, according to the BIOS and whatever configurations you have. If it's UEFI or BIOS settings, it's going to boot differently. And it's going to go find the disk that you said in your boots. It's either going to walk the network and do an iPXE boot and boot up, right? And as we're talking through how this works, if you needed to see that, like if you were like, Scott, could you show that to me? Yeah, I could show you an iPXE boot right now on my network. I do it right now. Anybody want to dare me? Anybody want to dare me to do it? I'll show you guys a Pixie boot right here. Watch. Let's go open up XCP NG. So we'll open our XCP NG. We'll go right here. Dared, right? Yeah. Dared. You won't do it. You won't go check that thing out. Ooh, the wife's messaging me. Maybe she's going to bring me food. I've been, like, working all day. Okay. Hold on. Let's go. We got some nodes down. That's fine. Let's go to just one of my Rocky boxes. And let's take this box and let's reboot him. Reboot him. Now that node is for all intents and purposes, he's an ephemeral node. Meaning that he is going to go down and come back up. Yeah, JW, people will dig into things that are kind of their area of expertise. And I would expect somebody that has front-end web knowledge to talk about what it looks like when that thing, you know, they might talk a little bit about the DNS, but then they'll talk heavily about how their page is being constructed inside of their Java app, and whether it's client side or server side. And now look, really quickly, I know what your focus is, right? Anyways, watch this. This box came up, it didn't know who it was, so it went and found the DHCP server on the network. That DHCP server said, I got you, bro, you're Rocky 1, and we're gonna go ahead and have you boot. Go ahead and TFTP from me, actually in this case it's HTTP, and download the kernel that you're gonna use in the initramfs. By the way, the kernel and the initramfs are two interesting things that have to be there in that system that we were talking about earlier, where as a Linux system boots, he is, so again, we hand off to the hard drive, we find a bootloader, typically Grub, the Grand Unified Bootloader, go spend all day in there talking about that stupid thing. It's fine, it's not stupid. The Grand Unified Bootloader, and then that is going to start up your kernel and your initramfs to be able to start mounting things and doing things. And then once it finally gets done doing all the instructions and all the things it needs to, it's going to kick off a switch to root, and it's going to become whatever the root of your file system is and mount all your file systems underneath. Those things are all kind of happening, and then finally, like, the initramfs is like, you're good, and then it kind of goes off and dies. And look here, this is a booting of a Rocky system. Yeah, so an iPXE is the network boot, exactly. This is a network boot right here. Wait, what the hell's going on? Oh, I thought there was an error. I thought it broke. I was going to say, I worked on this a lot because I want my lab. Look at all the Rocky boxes, guys. These are for all you guys that are doing the systems administration course. Also, you're going to think about it. Wait, you're going to go, wait a minute. There's only 19 of them, but there's like 60s, almost 70 people that said they're coming to the thing. What we're going to do is none of the labs are going to be done right there. All the labs I'm just going to have you guys do out throughout the week. So I think we'll be able to handle the load. If we can't handle the load, fuck it. I'll get more. I have plenty of network bandwidth here. I actually have a second network if I need to. I can move this stack to the other system if I need to. And we're just gonna do whatever the hell we want, right? We're so tired of following all the rules. This is my Twitch anniversary or whatever. Something. I don't know. Ops to dev. It is a network boot. Yes. Oh, I got to configure some stuff in there too. You're just gonna do local anyways. ICQ, that's fine. Look, I tell you guys, like, there's all this stuff to do, but I'm not gonna make anybody do anything, right? Like, you guys gotta allocate your time. Everything you do is a opportunity cost. You only have 168 hours a week. That's all there is, right? So, you gotta figure out, are you gonna give up those 20 hours of Netflix binge watching shows, or are you gonna keep doing them? Quartz 1, I don't know why I'm still making GNOME VMs. All right. Anyways, I don't even know where I'm at anymore. Ranger. All right, so symptom diagnosis solution. This requires an expertise, guys. All right. Systems thinking. This one, hold on a second. This one requires both. Hold on. Telling the wife, when you come home, let me know. All right. Okay. 3 hours anime a week. Yeah, IceQ, I definitely do more than 3 hours a week of anime. I mean, for sure. Like on Crunchyroll and stuff. I just watched one that, like, I didn't think it. I mean, I like anime, guys. I've been watching Dragon Ball Z since I was a kid. Actually, I think I was watching the original Dragon Ball on the weekends. Back when if you missed a show, you missed it, right? Back in the day. So, like, the original Dragon Ball was like, I mean, it was around in the 80s, if you guys don't know, 80s and 90s. Where I was going with that, though, is there was an anime that I didn't think could get me as tilted as it did, and I was legitimately pissed off watching this anime. I'll tell you guys what it is if you want, but I will not spoil it. Also, please, if you guys would, don't spoil it for other people, because that's jacked up. But I had a freaking anime that I just finished, and it tilted me. What was the name? Oh, it was called Tower of God. It was on Crunchyroll. I've only finished the first season. I haven't finished second season yet. But I legitimately was like, all right, you get your ass kicked. That's all there is to it. That's all I'm gonna tell you guys. If you guys want to go watch that, it's like a blood boiling tilt. And if you guys know what I'm talking about, don't be spoiling it for nobody. But it's like knuckle sandwich time, right? It's like that. I can't tell you, Ops Dev, it'll ruin it for you. But I'm just gonna tell you, if you guys like anime, go give that one a shot. It's on Crunchyroll, and it tilted me. So all right, so tilted means I was pissed. Like I would be real pissed. All right, systems thinking, guys. So of all the things that I said, some required expertise in the systems themselves, but didn't care about the individual implementation. Like I know Linux, so I can go basically anywhere and do Linux. That's true. But I don't know Linux in all places, so I do have a ramp-up time. Guys, like, when I go workplaces, it takes me, like it takes most people, weeks and weeks and maybe even months to ramp up to know most of the things. And for the most part, I only know the things I touch. So that I really liked Solo Leveling, ICQ. I watched that. Yeah, Solo Leveling was really good. I don't think I've watched Merciless, though. I haven't seen Merciless. Systems thinking here, guys. This methodology of troubleshooting is the hardest to attain because it requires you to be an expert in things and also to know this system. So this one is by far the most, this one is like the guy is a really good engineer and he's been with the company for 10 years. Or They're a solid, scientist, research scientist, and they also know the research methodologies and practices of this place. Not just like some rock star that comes in that doesn't know everything, doesn't know where everything's at. This person knows all that, and they're really good at finding whatever solutions they are. So, systems thinking is this: it's the process of analyzing all the interdependent components that comprise a system. So, we often talk about, a front end presentation tier, an application or a logic tier, and then a database back end tier. And that concept and that way of doing things is very basic, easy to understand. I can show you a picture of it. You'd be like, got it. Then when you go to deploy that as a company, you've got a web, you've got your web servers up front, and maybe there are some Lambda instances that don't even exist until they're being called by a front end load balancer, and that front end load balancer is in US West 2 and maybe over in Europe somewhere in one of their AWS regions. So now they got these funky long names, and then they're designed to do a different load balance between their primary availability zone and maybe a secondary availability zone that only gets partial traffic unless that availability zone can't handle the number of spot instances it spins up or something, right? Now, all of those things that I just made up as a word salad right there literally only exist in the presentation tier of that. And all of those things I just said would have long, funky AWS names. And even if you told me to go troubleshoot it right now, even though I just made it up, and I knew what those names looked like because I just, again, have been doing AWS and know some of that stuff, it would still take me some time to wrap my head around how the data are moving and what's kind of going on in the system there. Like, these are logical, but I wonder in what relation do you set the last one? In terms of data integrity or data protection or system integrity or just generally all possible points? I am not going to write a bigger list. So, yeah, so ICQ, this systems thinking like this is just that. How does, like, a user request? So a user request comes in, right? And this used to be super simple. We had a lamp stack sitting there, and a user request came in on a website. That front end form on a web page would do like a PHP query to a database. It would do whatever it did, and then it would be real easy to follow that process thread, start to finish, all the way until the page was presented back to the user, right? That stuff was like easy to follow. That was flipping easy. But this right here is like, nowadays, you've got these architects and stuff, and they're designing these systems where, I mean, just think about what's going on there. There's that presentation application data tier. For all of those tiers, there's a production one, and then there are, like, probably with 12factor.net, there are like versions of non-prod and maybe testing and stuff like that. So now you've got pipelines for all those. So pipelines for how engineers are pushing those in and moving those up and testing between them. And all of those things have problems. Those things have problems the most because when you're designing things, you are breaking things. That's like the nature of design, right? You're building things and you're breaking things and you're testing how they work together. So, God, there's so many moving parts. It's hard to even think about it just kind of messing around, like, as we're just kind of making stuff up, right? But systems thinking is the ability to kind of filter down and figure out how the data are moving in a system. And if you can do that, you are extremely valuable to a company, right? This is one that people strive for, right? And this is one that's hard to do because, again, some of these guys, like, they built systems 10 years ago and they're literally the only one that knows it because maybe they did document it well. But good documentation might have 200 pages, and how long is it going to take you to ramp up on 200 pages of extra data? 200 extra pages to fix a problem that's wrong right now, costing the company $5,000 an hour right now. That's a problem, right? Do you guys remember what this just happened a few weeks ago? Because I remember it came a few months ago now, and it came through the Discord. What were you guys talking about? It was like you could go make like so many thousands of dollars. I want to say an hour they were paying at one of the casinos in Vegas. Do you guys remember that? They needed a Linux engineer, and they needed them like now. They would have flown you out there to go work on that stuff. Yeah, zombie buffet. You gotta literally stew and just be there for a long time and just, you know, absorb as much as you can. Yeah, they were spending. They probably spent a lot of money for a good engineer. I don't know if they ever found him or not. I never looked into it. I'm very happy. And at the time, I was very happy where I am. I'm still very happy with where I am. But systems thinking it's more than just engineering. It's, I don't know, man. I mean, it's like I hate to say it's political too, but it's like, do teams like you and invite you to stuff? Do teams need you there to get certain things done, so they bring you there? It's there. All right. So then this isn't strictly speaking like the failure modes and effects analysis. I always just bring this up at the end of this talk. This one's always fun. This has been around from the government, the US government, since the like 50s. And the thing about it is, this is not truly a troubleshooting methodology, but it is a methodology, and it's very useful and it's very powerful to know. And I'm going to walk you guys through how I actually these are some numbers I actually did. They're not the whole thing. They're like a little part of it. That's why I hate every game day stream will be like, no politics, but what is privacy and data protection, integrity, archiving, and so on, then politics. Yeah, there's a lot. I actually don't care what people bring up around here, because I'll just ignore it. But yeah, like, oh man, American politics in general, just wonderful guys. All right, so what is the likelihood of it occurring? Okay, so here's failure modes and effects analysis, guys. Failure modes and effects analysis, technique that's been around in the U.S. government for a long time, and it's super simple. This is really easy to do. You talk all you want, ICQ. I'm surprised Robodom's not talking, or some of the other guys. You guys are welcome to talk all you want. So a systematic process to examine what could go wrong, and if it does, what impact might it have, and then what's the likelihood of it occurring, and what's our ability to detect and react. And if we can do these things, I want you guys to think about this. This is before the system gets implemented. No, you could do it while the system is running. That's how I did it. But this is before, like, so now you've been an engineer and you're starting to gain skills where you can help a project before it even gets started by bringing kind of your knowledge. Like, one of my favorite things, one of my favorite quotes ever is actually going across the bottom of the screen there. It's experience is the hardest teacher, gives the test first and the lesson after, right? Well, wouldn't that be really hard if, like, you guys all come to that Linux Systems Administration course and I start off with a test? I'm like, here's the final test. All right, now we're going to go learn all that stuff. Ooh, that's a good one. No, I'm just kidding. That wouldn't be fair if I was like, well, that's going to be like the most important doing that. So yeah, what could go wrong? And this is a systematic process. Again, I tell you guys all the time, this is not prescriptive, except the application of this is prescriptive. But what you put on this is up to you, right? So let's go look at it. This was me rounding up possible failures. So a big part of my job when I was the platform engineering lead, tech lead, by the way, I wasn't a manager, I was the tech lead. The big part of what I did was make sure that about 200 dev teams, they were developers, but they also, when I say dev, I don't mean they worked in dev. I mean, they were developers that worked on anything from dev to test to QA to prod in our environment, right? And a big part of my job was to make sure that those 200 dev teams, if they pushed a button and wanted a server of a Windows or a Linux flavor with all kinds of different customizations on it, that it popped out like a little gumball at the end, and they could take their little gumball and go chew it all off by their own without bothering me. That was a huge part of my job. Really big. We had about 5,000 servers. And we churned through some of those servers, I'd say a few hundred a month, were just like a churn. Like, people would be popping them up and destroying them and popping them up and destroying and asking for a whole bunch. And I had this heavily automated. So did M-Pesa, if M-Pesa's around. he was a big part of that too. But this was an effort that I took when I got back there, because I ran that team and then I left, and Pesa ran it for me, and then I came back. And PESA, not Pesa. There was VMware in it. Yeah, ops to dev. There was VMware, there was VRO, there was a whole bunch of implementations of Tower, and which is Ansible automation platform now, and all these other types of things that were happening. And what we did, so this was me talking about server builds, and let's look at this at a high level before we get into the super simple math of it. But there's a failure mode. What could go wrong? Then there was the cause. If I knew the cause, I would put the cause here. And then there were the current controls in place for either monitoring it or mitigating it, or both, right? So let's look at this. The initial image is unavailable. So there's images. They are VMDKs, which are virtual machine disks or something like that, inside of ESXi. So we had these VMDKs of hardened golden images, and they had certain names to them, right? And sometimes the ESXi clusters that would pull those up and instantiate them as nodes when we would hit the little button and have VRO, well, VRA would kick off VRO and run through the whole process. Sometimes that initial image could be wrong or not connected, or who knows, whatever thing. The library is not available. And we figured out that with monitoring of vSphere systems, we could eliminate that or very much minimize that from happening. So we did that. This is about to get kind of mathy, but it's super easy math. Automation job kickoff fails. So as the button's pushed, and then that's in VRA, and then VRO goes and runs along the system and is calling all these different tools. Sometimes it would go to kick off a job against some tool, and its credentials would be out of date. We had some kind of system requirement to like change service account credentials every 60 days or something. And this VRO tool, vRealize Orchestrator, just wouldn't have that updated tool, and maybe we didn't have a plugin back then to just go check it out, whatever the new tool was, because that's the way you do it now. And we would find this problem by building all of our server types every morning. And you say, well, doesn't that cost a little bit? It costs a little bit. Well, when I say cost, I mean it's like a sunk cost. You're already paying for the electricity on the machines, but it takes some processing time to build like the 20 different server types that we had, and then we just throw them away. We built them and we threw them away. So we did that daily, every morning, and that would verify that our system credentials were probably going to work for the rest of the day. Obviously, there's some point in time where you hit the 60-day mark, but the point is, for the most part, that day is probably going to be good. And then if it happened, like if it didn't build one day, we would fix it in the morning before anybody hopefully pushed that button to want servers. There you go. Agent registers, server backend fails. So maybe the version of some agent or the credentials or like the cloud. So you get these keys with like New Relic or Datadog. You get like an API key, and that API key is generated typically by somebody internal to your organization for like a specific project. So like this New Relic project has this specific data key, and then it sends data up to the cloud. Well, sometimes your version of the agent can be so. This actually happened with us with. Oh God, you know what's funny? I'm pretty sure it was Falcon. It was Falcon Strike. We had an older version of the Falcon Strike software, and all the newer versions pushed all the data up into the cloud, but the older version pushed it up to some API endpoint they used to have, and our old one wasn't going to work anymore, so we had to update all of our Falcon Strike. This is funny because now Falcon Strike will just update their own shit and break your stuff, so they don't care. Anyway, so hold on. So version of agent or credentials out of date, and then we did the daily build process to fix it. Then there's final build checks. You get to the end, but something fails, which could be any number of a billion things that could happen. An unknowable amount of things could happen to stop the final build checks from passing, so we didn't really have any controls around that. What we needed to do was just tighten up our final build checks, make sure that the system was good enough, right? It's going to have its little backpack on, it's going to have its little lunch pail, and you're just going to kick it out the door. All right, ICQ, couldn't you have written a little web GUI that could spin it up itself or use a policy missing not allowed? Yes, I wonder what your stance on cycling passwords. I've had some discussions. I'm not sure if regularly chaining ones at this point are truly the way to go. Yeah, you got to change passwords because of a thing called entropy. So you just have to change passwords. It's an unfortunate truth of systems world. But you also, like some people say, well, no passwords. Okay. If you have a certificate or you have a key, you also have to change that regularly because of entropy. All right. So now there's that. But then here's the thing. You might say, but doesn't government have a current STIG? Yes, they do have a current STIG for a 15-character password with an upper, a lowercase, a number, and a character, making for 72 total characters. And then don't they also with that have no 4 repeating characters can be the same type, so you have to change them often. And then you say, but I thought we shouldn't be doing passwords. But passwords are still supposed to be done because they're another factor of authentication. And if you don't know what that means, you need to go read up for, and I'm saying this for anybody, but what are the factors of authentication and why do we use them? And you say, well, I'll use a certificate, I'll use a key and a certificate, and I'll use whatever, I don't know, whatever else you want. Those are all the same factor of authentication. So now you're not doing multi-factor, you're just doing a whole bunch of the same factor. And that's not as secure, proven over and over again, and research and all that kind of stuff. But anyways, the whole point of changing passwords is entropy. Go look that up. All right. So we do all this. Now let's get to the math. You must assign a number. You must assign... Why don't I have this on here, guys? God, I'm stupid. Hold on. Number must be between 1 and 10. All right? So this has to be there. I don't know why I didn't have that on here. But for your failure modes and effects analysis to work properly, you have to then assign a number to these in a meaningful way. Okay? Severity times probability times detection gives us an RPN, a risk priority number. Risk priority number, the higher is more impactful. Some people might call this, you might, depending on where your background is, if you're from medicine or something like that, or even in like a combat sense, triage is the idea of assessing the thing that's going to cause the most damage or the thing that's going to be damaged the most. Triage is protecting, in medicine it's protecting life. In a battle, it's causing damage, right? It's causing damage, and in the infantry motto is closing with and destroying the enemy by means of firepower and maneuverability, right? That's not really the motto, but it is the model. All right. Anyways, number must be between 1 and 10. So then we come here to those things I just said up here, and we had to assign a customer impact. How much does this affect the customer when it happens? And these are, they're arbitrary. Well, they're not arbitrary. They're subjective at first, but you should tune them down to be as objective as possible, right? Likelihood is what's the likelihood of them happening, and there's a whole bunch of ways to determine likelihood of things, guys. We talk about mean time between failures of things, that could feed into it. If you know how often disks are supposed to fail in a system, then you can be prepared to replace those disks at the appropriate times. Likelihood can also come from historical data tracking that you've done. And then what's our detect and react? Do we have a way to detect and stop whatever it is from happening, or to continue our process? If something breaks our process, that breaks everything after it. If you're talking like Six Sigma, you failed all those later tasks because you broke something earlier. So detect and react, how well can we detect and react to it? And then we just multiply them. 2 times 1 times 5. This isn't one of those games where we all sit around and argue about how math works, right? You multiply them together and you get the right number. All right. So anyways, that's, if you guys have never done that before, that's our general troubleshooting talk with the Professional Linux Users Group. Also, I have that up on Discord, so that's out there. And that's it. Let me make sure I saved that because I fixed a couple of things. Let's talk about, we'll do this one. So we'll go, do I have this one here? Intro to Cloud Computing by me, right? So we'll come down here and what is cloud computing? What are the cloud deployment models? How do they work? What do they kind of look like? What are the cloud service models? And then what are some cloud security concerns, cloud security providers that are out there, the common public providers, right? And then common issues in cloud environments. So if some of you guys have like only ever heard about the cloud or not really messed with it much, let me talk to you a little bit about this. The heck are these, right? All right. I'll tell you guys a little bit about the cloud. All right. So what is cloud computing? Normally I have a shirt on. I have a shirt for this when I talk about this, but this is a kind of common idea, And the reason this is a common idea, the reason this idea exists in this form, is as engineers, when we draw things, when I don't want you to think about the thing I'm drawing, I make it a cloud. Look, here's an example right here. When it doesn't matter, when it's not germane to the conversation, like we don't care. I spelled it right. In this case, like the internet, I don't care where you come in from the internet. If you come into streamer1 at prologue.asuscom.com on port 22, you will be a jailed user and you will get into our lab environment. Ops to dev, I do have these, and yeah, these slides are all up in the Discord. Yeah, yep. This is this talk is called Intro to Cloud Computing. It's up there. Yeah. Okay. So what is cloud computing? It is not a general idea. It is not a generic thing, right? It is, Daddy, what are clouds made of? Linux servers mostly, okay? All right, so the cloud is actually very well defined. So it's not a abstract concept. Like as engineers, we go like this, and we say, don't worry about that. But it doesn't matter to, that is not what we mean when we talk about the cloud. The cloud is very well defined. There are essential characteristics, there are service models, and there are deployment models. By the way, I always show this doc, the NIST standard 800-145. You can just Google that and it'll come up. I'm going to click on this, and I'm going to make fun of it the whole time, but it's because it's deserved. Let's skip the verification. Let's go look at this document real quick. This document, according to my Chrome here, is 7 pages long. 1, 2, 3, 4, 5, 6, 7. Right? Do you guys all agree with that? It says 7 right there. Now watch this. This is who we are. This is what we're doing. This is a report. This is acknowledgments and changes. This is the authority by which we publish this. And here's the data. There are 5 pages of these 7 pages where they're like patting themselves on the back as hard as they can for writing it. And then there's actually only 2 pages of data in here. This is a TCP header around data right here. This is like the worst thing ever. But the data itself, this is really good. It's really good. Here are, according to NIST, the standards for the definition of cloud computing. And this is used in ISC squared. This is used in everything. Yeah, it's TCP header. It's all this overhead for nothing in it, right? It's just an ACK coming back from all the other stuff. On-demand service, broad network access, resource pooling, rapid elasticity, measured service. Those are the essential characteristics of the cloud. I'm not going to read them all to you. You guys can sit here and read them for yourself while I sip on water slowly. I just take a break on this and leave you guys to read. That'd be terrible. I'd read it to you, but I don't want to. No, I'm just kidding. On demand, yeah, customer can unilaterally provision computing capabilities. Now there can be limits on that. You can't just provision above some type of limit, but the limit should be published. But you should be able to get server time or network storage as needed without talking to a person. I shouldn't have to go put in a request on a piece of paper to get more service of some type. Not often that there's no wrong solution, because I hear that often in code, but I write there are wrong things. Stop being. Yeah, so broad network access. So there's all these essential characteristics, and these are the things that you need for the cloud to work properly. In fact, in another talk that I think I have in the background here. No, I don't have it. I don't have it up. But there's virtualization was huge for the cloud to be able to work because of the resource pooling. We could have multiple people on the same system. We could squeeze more and more out of these servers than we used to be able to get, and it's there. So okay, rapid elasticity. Capabilities can be elastically provisioned and released, meaning I can scale up, I can scale back down. Typically, we call scaling out and scaling in the horizontal scaling of a service. Horizontal scaling of a service is always adding more resources to the side. Certain services scale better horizontally. So what does that mean? If I have a load balancer and I have one web server behind it and it's just working like that, adding another web server to the side, easiest thing in all the world. You just clone that web server. Two web servers sitting next to each other, don't even need to know who the other web server is. They don't even need to know that there's 10 of them sitting there next to each other. They just get the next request down from the load balancer. They don't give a shit. That is really awesome for scaling out, horizontal scaling. But a database server sitting there churning through database requests, and you put another database server of the same side next to him, he'll be like, where's Conor McGregor? I need Conor McGregor. Who's that guy, right? If you guys are familiar with the old Conor McGregor memes. He's like, who's that guy? It doesn't matter. He's still got to serve the request. So database servers tend to have to scale up, what we call vertical scaling. They get bigger and more powerful. And there's costs associated with that, but there's also costs associated with ever trying to scale those down later, right? But anyways, this is essential characteristics of the cloud. This is a well put together doc. Then there's the software as a service, platform as a service, and infrastructure as a service. And I've often said they need to add at least one to this, which is function as a service. Function as a service, FAAS, should absolutely be there. There are a million other ones that people have made up that I don't think really matter because they fall into one of the other ones. But function as a service is not any of these. You can go look. Function as a service is its own thing, and it is by far the most used resource in the cloud. Function as a service, by far and away, in AWS, it's Lambda. In Azure, it's Azure Functions. And then Google Cloud Platform, I have no idea because I never studied it. but it's one of those things. I think they're called Google Functions or something too. And then the deployment model's really easy. Is that what it is? I don't know what it is in Google. I've never done the Google side of things. All right, so anyways, oh, look, Ranger's walking around. Ranger's being an old dog. Look at him. Look at him. He's like, how am I going to lay? I'll lay this way. I'll lay that way. Nice and cool downstairs. He's pretty happy. So, all right, anyways. Here's our essential characteristics. We just saw it right there. All right, service models. We just saw it. We're not going to go through them again. You'll see the service models again here in a second. So, deployment models, again, just a bunch of information here. Yeah, Uzochi. Yeah, that the concept of function as a service would directly relate to the term serverless. Yes, but hold on. Before I say that universally, let me show you guys. For people who do want to explore serverless, or in some ways want to explore this concept of what we call function as a function as a service, event driven. Who here has heard of event driven? Right. Event-driven programming, event-driven systems, architecture, whatever. There's a thing called serverless land. And serverless land is the place you go when you want to get your developer associate from AWS. This is one of the places you go to study. There's a lot of things that you should study, but these are the major functions that deal with not having to have a server. Now, I know people are like, there's always a server somewhere, and they pat themselves on the back and they fucking go back to eating cheese or whatever the fuck they do. But I'm just going to tell you right now, the difference between server and serverless is, do you need to pay a guy like me to run your servers? And if the answer is no, then it's serverless. But if you guys, I know, Zochi. I'm just saying, people get so mad about serverless. And they're like, there's just a server somewhere. And I'm like, okay, are you paying me to run that server? No, then it's serverless. Why do you got to be a rat about it? Like, people are like ratty about stuff. And it's like, everybody knows there's a server, but you don't care about the server. You can't point to it and say it's Rocky 1 in my home lab running that, because you don't know, because somebody else is paying a guy like me to run that server. So, I don't know. Serverless is a really apt way to describe it. You're not running servers. You're letting other people run the servers for you, and you are simply using a function on top of it, which is why I think function as a service should be there. Oh yeah, I'm fine. I don't care. Running VPs instead of servers. Yeah. So anyways, my point is, this is a good place to start. And by the way, if you sit here long enough, yes, this thing is moving up and down, and yes, it bothers the crap out of me. Because I remember I was sitting here one day and I was doing something, and I was like, is that thing moving? And I go back to doing it, and it was like just moving right at the corner of my vision while I was doing something on one of my other screens. Yeah, that thing moves. And it's one of the most bothersome things I've ever seen. Yeah, look at that. Somebody was like, everybody thought, they thought, could we do it, but they never stopped to ask themselves if they should, right? Look at that thing. It's so subtle. Waits for you to look over here, and then it just goes like that on the corner of their eyes, right? I left my mouse there so you guys could see how much it was moving. Bothersome. Anyways, all these tools, though, super useful to understand. And one of the reasons I like showing you guys this is if you've never done this, you go over here to example code and you look at like snippets or patterns. Patterns are great. When you're looking at the patterns, you say, because everybody always asks me if I've used Pulumi. I've like played with Pulumi, but I haven't really used it. And then there's the serverless framework or Terraform with modules. There's the cloud development kit, which AWS really wants you to use their cloud development kit or their, what is this? This is the server something. Anyways, point is, let's say you want to do Pulumi and you hit Pulumi and they will give you examples here. And then you can go view the pattern. Go view the pattern. You can even go get the Git, or you can just look at your Pulumi right here and modify it for your instance. Okay, there you go. All right, so what's Ranger doing? Laying there. All right, so that's cloud deployments. So here's the deployment models. There's private cloud. Private cloud is you just run some cloud for yourself. You can pay for it to be locally. It could be locally hosted. You could do cloud yourself. But it's an infrastructure provision for exclusive use by a single organization. It can be spread out across multiple different sites, and it can be all around the world, and it can be completely 100% private. A lot of companies, surprisingly, do run private clouds. They don't, it's not all public stuff. All right. Community clouds. You're a dentist's office, and you've got to follow HIPAA, but you don't want to spend $3 million to get all the infrastructure to run HIPAA locally. So you and 3 other dentist's office or multiple dentist's office in one state that are all under the same basic rules and regulations, you guys all pay into a collective, and you maybe pay licensing fees or whatever, and you stand up your own community cloud where then you can pay, you know, a few developers and a few engineers to run all this stuff for you, and then you all get some of those resources, and maybe if you go over certain limits or something like that, you pay a little more, but you know, that's probably a good problem to have because now you're making more or whatever. But a community cloud is made up of like type organizations, and they have typically the same requirements and policies and that kind of stuff. Public cloud, this is like Azure and AWS and stuff. Bunch of companies coming in and they're doing all of those processes of allocations for themselves and scaling up and all that stuff without ever having to talk to a person. That's the community public type cloud, right? And then hybrid tends to be all the other stuff that's like put together from all of this, right? So hybrid is people are moving into and out of all of these types of architectures all the time. Traditional infrastructure, you might say, because I know people that are, you know, we have quite a few people in our community that are out in the cloud, guys, and that work it. And I will tell you, there are still things that on-prem does better, and I'll tell you what they are here in a second. Does the function spin up a server instance, run the function, and then spin down the instance? Is that how it works? Yeah, Uzochi, as a very simple, simplification, like almost an oversimplification, yes. But what it does, it's not a server instance. It's actually typically like a Docker instance. And then the Docker isn't even Docker anymore. It's like a Firecracker tool or whatever. But it's a container. And then that container will run the function for as long as it needs to. And then typically, so there's all kinds of theory that goes into this. Watch here, I'll show you. If you guys want to dig into that. So because somebody asked, we'll go dig into like Lambda, warm start containers. Let's see if we can find a good blog post for this, because I'm no expert in this, but I can tell you that there's some really good like warm start. And what'll happen with a warm start is if you start a container and it takes 300 milliseconds to start that container up, what if you keep that container running and you can run the next 10 instances of that Lambda function in that same container. So now you're not spinning up a server instance, you're spinning up a container instance, and then you've got 9 other instances out of it without paying that 300 milliseconds up front. And you say, what, is 300 milliseconds a lot? I don't know. 300 milliseconds might not be much, but what if each of your instances of like Lambda was going to be like 700 milliseconds of length? And then now, if each one of them had to start that container with its own 300 milliseconds, they're now a 1 second Lambda instead of whatever. Oh, this times billions. But watch this. Hold on. They should have it in here. I think this is one of them. This is, so yeah, Lambda downloads your code. Code is stored where Lambda can get a hold of it in an S3 bucket that you don't ever see. They start a new execution environment. They execute the initialization of the code. They execute the handler of the code. And this is the cold start duration over here. And then this is the invocation part of it, right? And again, I'm not an expert in this, but I can at least show you guys how this works. So look, this is how the execution environment lifecycle works. So this is the cold start part, and then this is the execution of your actual code. And then maybe you update the code, and then they have to re-cold start. But if you don't do that, if you don't update your stuff, then look at this. Now you start over here, and the cold start's already there. Now the function was ready the whole time, and then you got your invocations just as you needed them. So there is a whole bunch of tuning. Oh man, look at that little dot. Oh gosh, that's in the web page. That's not even on my, I can't reach up and knock that off my screen. Look at that thing. You guys see that? I hope I see that. I was gonna say I'm losing my mind if not. Anyways, that guy needs to get that out of there. But anyways, my point is, look at this stuff. So he talks about how these 6 execution environments already prepared when the invocations occur, and it can save time. And this looks wasteful, except you're talking about they can have multiple stacked. Watch this. So now there's API and simultaneous requests, and then now this is where you start to have, you already have the cold start and the environment's already stood up. And this guy talks about all this stuff. But my point in saying that was, the question was, does the function spin something up? It doesn't. It spins up. It doesn't spin up a whole server. It spins up a container within a server. And then look at the kinds of things that can happen where you can really start to, you're paying over here compared to this time. This is, as far, when I say paying, I mean like paying the opportunity cost of not having it with overhead. What's the overhead on that? Maybe 5% of the total. I'm just kind of eyeballing and saying that's about 1/20th, maybe. Yeah, that's probably about right. 1/20th or so. If that's 1/3 of each, that's about 18. So yeah, that's about 1/20th right there of the total time. And then they get into how that works and stuff. So anyways, that was a question that got asked, your Ranger. All right. So here's the service models. You've got your traditional IT, you've got infrastructure as a service, you've got platform as a service. And as you move from left to right on this drawing, you take more of your management away, but you pay a little more for the convenience of having it delivered as a service. But then I always ask you guys this: who's responsible for the data? Who's responsible for the data, guys? Who is, at the end of the day, if the data gets lost, who gets on the news and they're like, this company lost your data? Do they say you and AWS lost the data, or do they just say you lost the data? It's you. It's always you. It'll be you. Guys, one of the things, so I worked at AAA, right? AAA. That's what it was, AAA. Now, some of you guys might not know this, but companies will go out and companies will do surveys and ask questions about, not quad A's, just AAA. And companies will come out and they will ask questions of people in surveys. But what they really want to know is do you like their company? So companies will ask stuff about all kinds of things, and they'll get sentiment of analysis for how much people like AAA and Kroger's grocery and Safeway grocery and Amazon Web Services and people will do surveys and stuff and send this data all over the place, and 100% of the time, like in the U.S., just U.S. These are U.S. surveys. The company that's always on top is AAA. I bet you right now, for you guys that heard me say AAA, you were like, Oh yeah, I never even thought anything bad of them. They come and save people on the side of the road, and that's what they do. And everybody loves AAA. I never heard of anybody say anything bad about AAA. Hold on. So not AAA, AAA. Anyways, where I'm going with that is our company. When I worked there, we were like a 93, 94% like people recognize the name, and then also like a 90, like it was like 96 or higher. People liked the name. We were like one of the most AAA, if you know what that is in the U.S., been around since 1906. It was a car club in California, and then it became a big car club everywhere. And there's 50 individual. So, anyways, it doesn't matter. But my point in saying all that is highly thought of company. People really like them. One of our main things, like, and I used to tell my junior engineers this: do not put our name in the news. Do not lose people's data. Do not, like I used to tell the engineers this. It's like our job is to keep us out of the news because our company has such a high favorable rating that like almost everything we do, whether it's insurance or whatever, people are like, oh hell yeah, I like AAA, and it's like we don't have like we weren't so big that we had like name recognition like Geico or something, but it was pretty big, right? And I didn't do marketing or any of that stuff. I'm an engineer. I just happen to know that stuff. Anyways, where I'm going with that is if you lose the data, it's always on you, 100% of the time. Another way to say that is this: pizza as a service. If you've ever seen pizza as a service, who washes your hands? In all these models, if you don't wash your hands, who's going to wash them for you? Like if you go to sit down at the table and you didn't wash your hands, like going to the bathroom or whatever because you're nasty or something. That's so funny to me. because you didn't wash your hands, nobody's gonna do that for you, even in this model, right? Even in the one all the way to the right, software as a service, your job is still to move your data up there securely and provide the proper users only with access to those systems. That's what your responsibility is in the software as a service. But nobody, like, again, so what's software as a service? Okta? You guys ever seen Okta? Okta's like this big, like, third-party type, implementation of like what we call a single sign-on, SSO. Everybody can get in. Well, if you go and you give everybody access to your Okta and you make everybody an administrator, well, you're going to lose your data, and you probably deserve to have your data taken from you, right? By the way, thanks for the follow. Requirement. Hopefully this stuff's useful to you. All right. Pizza as a service, like software as a service. All right. Cloud security concerns. Now, this right here, this model right here, ICQ, I literally forgot what I just said. I have literally forgotten it. What did I say? Hold on. You're always responsible. I think that's what I said. All right. This cloud data lifecycle comes from CCSP. Oh, Okta. Okta is a single sign-on, SSO. And even if Okta loses your data, nobody's going to blame Okta. They're going to blame you. That's all there is to it. It's going to be in the news, and your company is going to have lost PII, which is personally identifiable information for people, and it's going to be bad. And if you're in Europe, you're going to get GDPR violations, and you're going to owe people money. And if you do it in the U.S., you're probably going to spend some time or fines in jail. And again, like, you guys might think I'm kidding, but some organizations really care about their name. They really care about how well people like take their name in their mouth. And AAA has a really good track record of just being a company that people like. Again, 20-something people here. Probably a few of you have had interactions with AAA and we're like, hell yeah, I like AAA. They do pretty good. Like, even when I was mad at my company for because I should have been under the free roadside service because I was working for them, even though that I didn't get that and they made me pay when they brought a battery out to me, that was still better than not having a battery in my damn vehicle. And I was in California, far away from home. I couldn't have the wife come pick me up or whatever. So, all right. So here's the security in the cloud. We don't have control over the physical network or devices anymore. We're in the cloud. We can go spin up a virtual private network right now. The virtual private network, VPC, virtual private cloud instance in the network. you know, up in AWS or something, and I would have no control. I could program the crap out of the access control lists. I could program the crap out of the routing table for my different subnets. We do all kinds of fun stuff. But if they turned the power off to those devices, I would have no way to get those turned back on, ever. If they were like, we're just going to close down that whole region you're in, I would have no control. Likewise, if somebody were to compromise their devices, I would also have no control over that. So, well, even if you do lose data ICQ, it's just a free online backup. Remember that, guys. If you ever lose all your data for your company, it's just a free online backup. It's a free online backup service. That's all it is. Okay. So here's the thing that we need to know about data. Data must be encrypted at rest. Encrypted at rest at least an AES 256 encryption. Data must be encrypted in motion, and it must be encrypted in motion with at least TLS 1.2. But TLS 1.3 is preferred, and TLS 1.2 will be deprecated eventually, but it doesn't matter that much. There's just some overhead at the front of the connection. So, since we no longer control the infrastructure, we must use what's called cryptographic erasure, meaning that I have to have keys, and when I want to delete the data, I can tell them to delete the data, but I don't know that data's gone. I need to then delete the keys to ensure that nobody can have access to that data. Now, there are tools out there. If you guys want to go play with some fun stuff, there are tools out there that will rip apart drives, and they'll break them if you want them to. But there are tools out there that will cryptographically erase drives by striping them and doing all kinds of other things. There's a really big company. One of the guys mentioned this the other day, so I need to bring it up. 45 Drives. If you've never heard of them, 45 Drives makes the Storinator and all these other kind of things. Now they make the Proxinator. But watch this real quick. Hold on, we're gonna pop this up real quick. Look, they've got all these different companies. I have a slide deck that I show you guys sometimes where years ago, over almost 15 years ago, or almost 10 years ago now, I built one of these out for a company to have just this huge mezzanine storage. And these are still great for big storage. But look right here, mass drive racing, mass drive wiping. It is the Destroyinator. And all you got to do is drop these drives in there, and it will go, and it will clone a master disk and sanitize disks. It'll just wipe disks for you all day if you want it to. If you have so many disks in your data center that you just need to wipe them and give them to other people or whatever, they'll do it. And they will do all kinds of compliance standards. So, let's see. Do we have kill disk? Let's see if kill disk. I wonder if that's open source. Is there an open source version of this? Active, it follows all those. It's on SourceForge. Geez. You know the dedication you need to still be on SourceForge nowadays? Probably nothing's been updated on there in a while, but let me go see. I haven't used this in years. If this is the right, this is it. Yeah. This is. Yeah. Look, I don't click on stuff like that, but let's go see if there's an open source version of it, which probably hasn't. One download this week. Last updated a couple years ago. Scary. Kill disk is a program written in Python for Unix-based systems for wiping hard drives. Can wipe a hard drive using all zeros or random data as many times as you want to specify, right? So that's the crux of it. How many times do you want to go over this data to make sure that somebody can't get it back? I have personally seen data pulled back off of a hard drive that was overwritten 31 times and then dropped in a lake for 2 years. That was a thing that happened in like the early 2000s. Somebody did this project where they like dropped it in there. And hard drives are sealed. Most of you guys probably know that. That's why they don't do well under pressure if you take them up in airplanes. I told you guys that story, right? The one guy that was brilliant, but he just couldn't tie his shoes. One of the engineers I used to work with. And he was a research scientist, actually. And he kept having these drives failing because he was in like sub-zero weather in the back of an airplane. And he was at high altitude gathering the satellite data and he was doing scans with SAR radar, which is synthetic aperture radar, if you guys aren't familiar. That's also a good fun one to go play with if you're looking. Anyways, older time in my career when I used to do that stuff. But anyways, so cloud data lifecycle looks like this. We create data, we store it, we use it, we share it, we archive it, and we destroy it. With helium? No. I don't know. Yeah, I don't know what they seal them all with ICQ. I got out of hard, like, I do hardware, like setting stuff up in racks and stuff, but I haven't been down in like the trenches of like disks and that kind of stuff for a while. So I'm a little spoiled in that regard, probably because I focus on the Linux, right? But I still do all that stuff. Yeah, ICQ. I don't know what's inside of it. I can just tell you they pop if they have pressure changes too fast. You can damage the seals on them for sure. Well, as you could with anything that's sealed, right? So guys, this data cycle, right? And by the way, if you ever take a certification test, one of the things that you have to do on all certification tests is sign a non-disclosure agreement. Like, you're not going to tell the questions. So I can't tell you any specific questions, and one, I don't even remember them, and two, I wouldn't tell you if I did. But three, I can tell you what they were kind of generally like. So if anybody here is ever going to take their CCSP, I lost my recording right as I went to say that. If anybody here is ever going to take their CCSP, which is Certified Cloud Security Professional from the ISC Squared organization, that's really funny. Anyways, they will ask you questions like this. So one of the standards for that test is you need to know this cycle. You need to be able to repeat this without looking at it, right? You need to know this cycle. But one of the things they ask is which of these two would most likely happen at the same time? Or which of these two would most likely happen in the same, like, request, web request or something, right? API call or something. And you need to know, as you look at this, what's happening with data, what's happening with like logging requests and logging from a request and those kind of things. You have to know how this works. We create and store data almost at the same time all the time. And we use and share data almost always at the same time together too. So if they showed like create and share and archive and store and use and destroy, those things are across, so it wouldn't make any sense. Hey, how's it going, Midnight Simon? I see you've been streaming a lot more lately. I need to get in there. I've been doing, I've been working. But I'm hanging out today. Apparently it's like my streamiversary or something. So, yeah, man, you're on ads. Oh, no, you're not supposed to get ads when you come in. They can't give you ads as you come in. I'll take it up with management. Some of you guys probably didn't. Some of you guys probably didn't get ads. And you're probably like, who the hell's this guy? Well, I'm just a guy that hangs out on Twitch sometimes. I worked way too long today. I was in a data center. I'm hardly ever in data centers, guys. This is my data center right here. I just hop onto one of my Linux boxes. Oh, where are my Linux boxes? In my home lab, right? I just hop on here. I hop on here. Earlier I was showing you guys how when we reboot one of these nodes, let's just go abuse this thing. It'll just pop up and it'll iPixie boot and come back up. And then we were pinging and we were talking networking. Right now we're talking cloud stuff because I just don't want to think right now. I'm just brain dumping on you guys. And I was telling you guys specifically, some of you guys, oh, thanks for the Runamucker for the gifted. That's always nice, you know. Keeps me motivated, keeps Midnight from having to see ads and that kind of stuff. So that's always good. But what are we doing right now? We're talking through like the cloud. Like people know that the cloud is this thing. Oh, look here. This is Pixie booting. So this device doesn't come up from a hard disk. It doesn't come up and boot through the normal methods. It comes up and does an iPixie boot and grabs a container from Rocky Linux. And in that container, there's a kernel image and initramfs, and it's going to boot. And then we're going to have all of these Rocky nodes for our Linux Systems Administration course that we're starting. When are we starting it? This Saturday, right? So we go here. Oh, whoops! Don't want to go there. Don't want to go there. Where the hell am I, guys? I don't know how to do stuff. So we come here. We go popping way up here, and we go to our events. And we have a Linux System Administration course starting this Saturday where I'm just gonna, do all the normal stuff that I do as a systems engineer and a teacher, and I'm gonna show you guys like what you got to do to be a systems administrator. You got to know how to use your tools. You got to understand these different things, and then we go. And then we've got a guy who codes for people that do like coding, and he comes in on Sundays. It's my buddy Salty Catfish. He's been a professional coder, software engineer for like 10, almost 15 years now. I take it back, 15 years. And the whole time I've known him, the last 5 years, he's been a lead. And what does it mean to be a lead? Well, when he runs this, he has you guys pushing stuff up to Git, knowing how to learning how to branch things and work on a team. That's how he runs that low code cove. So for people that are like, hey, I can do all the algorithms and I'm super smart, that's wonderful. But I guarantee you, if you go talk to Midnight, thanks for coming. But if you talk to Midnight about it, he would tell you working on a team and coding skills are mutually exclusive things. You can have all the coding skills in the world and you might be a shit team player. So there are things that you might want to learn and know about things that will make you a better part of the team, right? Productive and that kind of stuff. So anyways, that's what he does. That's what Salty does. And they build a bunch of bots for in our Discord or whatever. So, all right. So, back to this. Look, that box is booted back up and he's back in. We can go abuse that box and do all the kinds of things to it. We can typically though we won't do it through the console. We'll jump over here. We'll SSH select Rocky 1. What? I don't need that. I don't need to. What? All right, whatever. We'll do it later. I shouldn't have to answer to that. All right, no, it's because my jump box is outside of the cluster. It's not a component. Oh, anyways, it doesn't matter. So this is the cloud data lifecycle. All data that are created in the cloud are used in this way. We create them and we store them. We use them and we share them. We archive them. We destroy them. And then all of the discussions that we want to have around the data should start to, fly from here. Like, well, so we're going to create it. How are we going to create data? Well, we're going to create data in the sort, you come in through an API gateway request in my AWS cloud, right? So you come in through an API request. That API gateway goes and sends you off to a Lambda function. That Lambda function maybe, goes and queries some backend Dynamo database and pulls down something. By the way, that Lambda function, you can write that stuff in JavaScript. You can write it in Python. There's a billion different examples on the web. It doesn't take any kind of smarts to do that, I guarantee you. Then, or maybe your processing has to be done by a server because you have some old bespoke code that nobody knows how to update anymore. So you've got to run it on a server. That's cool. But that server, even when you spread them out, you still have to build a queue. So now that API gateway comes in and just drops something into an SQS queue. And then that server that's like, I'm kind of tired. He just goes and grabs the requests as he can get them. And then you, as a competent engineer, gather and just keep track of how many SQS queue events do I have that haven't been read out of the queue yet, right? Yeah. Lots of queues. So anyways, where I'm going with that is that right there, all of that was still over here. Then we start to use the data. Oh, by the way, as we go to store that data, so he's generating requests, he's reading stuff, and he's making logs. So logs are coming out of there. Logs are going to wherever logs go in the cloud. You can take those logs and you can feed them directly into like an S3 bucket. You can throw them directly down into, there's all kinds of kinesis things that can happen to logs, and you can chew them up and go and throw them. So there's all kinds of crap you can do. But my point is, like, the cloud data lifecycle, you need to know this if you're going to go take a certified cloud practitioner test. Certified Cloud Security Professional from ISC Squared. All right, which is very similar to like I would say when I passed my CISSP, that data over to CCSP was like 70% of the data. And then I just needed to know like a little bit of the other stuff. Needed to just brush up a little more on some other stuff. But I was already, when I got my CCSP, I was already let's make sure I say this in order. No, I was only a Solutions Architect Associate at the time. And then I got my Solutions Architect Pro after. Yeah. I haven't gotten a cert in a while. I gotta go take one of my certs. All right. So defense in depth. This is the traditional way we used to defend servers, right? And you say, wait, You have a perimeter. Yeah, you had to physically have like a server somewhere inside of a rack, inside of an enclosure, inside of a aisle, hot or cold, depending on the way that the exhaust of the back of the server's facing. And then you had to have a typically an enclosed space inside of a building. And then you had a building, and then you had how you actually do your outside landscaping and how you do your lighting is part of perimeter security for servers. And you say, I didn't know all that. That was part of running and managing servers for a long time. Running our own data centers, this was absolutely part of it. Then you had the network, and then and the network connected out. So you have your LAN, your local area network, which is typically things that you own, and you're just paying to turn, you're paying this switch to turn electricity into heat, and that's just costing you money. But that thing then goes and, goes to a router and goes to whatever and connects out to the world. We can talk about all that, but then that is a place where people can penetrate into your system. So we would have firewalls and layer 7 gateways and any number of names of things that we would want to protect our systems with here. Now, instead of having just strong outer networks, we have zero trust on the inside. So everything that talks to everything else should be doing so with a certificate, right? These are the like general ideas of like engineering. If anything I'm saying, is interesting to you, you should be taking notes, right? Like, look, I even have notes from all my work that I was doing today. But you come down here and you do your notes or whatever, and you keep track of this stuff. I'm going to show you guys right here a book that I really think that you should read if you want to get better on that zero trust spiffy. So spiffy is solving the bottom turtle. This was published, taking a while to download. Solving the bottom turtle. This was published, look, by Book Sprints Methodology. Its content was written by authors during an intensive collaboration process conducted online over 2 weeks, and it was sponsored by Hewlett-Packard. And this is a bunch of people. Some of these are, at least one of these is a member of our community. And, this is how they went around figuring this out. Okay, so we go here. This is the bottom turtle if anybody needs it. Boom. There you guys go. All right. So there's range. Look at that dog. All right. So defense in depth, we have our network, and then within our network, each individual host should be protecting itself. It should be doing that by only allowing access on certain ports, only allowing access on those ports to authorized users. Those authorized users should then have access to the things that they should have access to, right? And that should be properly partitioned off through access control lists and all these other things that are built into the system. This is one of the reasons SE Linux is so popular right now. SE Linux is just SE Linux. Just another way of partitioning and actually labeling processes so that the processes and the processes and the file systems match. So a process has to be able to access a file because it has what's called a context with it, right? And that's all at the host layer. And then the application has to deal with that stuff as well, because the application has to deal with the rules of the host. And the application should be only looking at data, what we call data in use, as it needs to. It should only encrypt all the data that it needs to and no more, no less. It should be cleaning its memory out when it's done. All these things should be happening with the application. And then you've got your tasty little block of data. Your data needs to be locked up. You need your data encrypted. It needs to be at a minimum. I say this all the time. AES 256 is the minimum encryption online. Again, when you ask me why, it's because of entropy, and I'll just keep saying that until you go look it up, right? What it means. So the data has to be protected around this perimeter and around the way this actually works. So we come to data, defense in depth in the cloud. You no longer have physical security. I don't even know where those devices are anymore. I don't know where they are. I wouldn't know how to even lock the door. I wouldn't need to know any of that stuff. Hold on, I got a question. ICQ. I am actually curious what to do if you tell someone, I tell you this is insecure, and if you want to take the risk, then he says he will do so. What would you do as a paper with sign work, like if he's a man? ICQ, I document everything. So like if somebody asks me, to do something, or like I'm being asked as an engineer to like compromise something, and I've had this happen before many times in my career, then I just, I'll ask them for clarification, and I'll get that clarification, and then I'll let them know that I can't do it because of whatever standard, right? The standard that's stopping me, even though I'm not a security guy. But the buck doesn't stop at the security people. The buck stops at the systems administrator and the engineer. Like, I'm the guy who runs the systems. People will always blame me. So when I just can't do something, then what I'll do after I've got clarification, I say I'm not going to do it, and they tell me I have to do it, then I just have to start sending it to higher. And that's what I would do, ICQ. And I tell you guys, there's a few hills that I'll die on as an engineer. There are a few things that'll make me take a badge off and walk out. And I've told you guys what they are before. So, all right. So defense in depth. You don't have the physical security anymore. So now if you're in the cloud, if you're doing anything off premise, your identity and access is your new perimeter. It is, and when I say that, I mean identity access acts as the only way that allows people to get in or out of your system. Your identity and access is how do we authenticate people, and then how do we authorize them, and then when we're done with that, how do we audit it, right? Those are the three, the AAA. We no longer have control of the perimeter, so we need to protect our data at rest. So even if somebody loses control of their identity and access, if somebody loses their identity, they get compromised, they shouldn't have the power to do hardly anything in the network. And then data should be protected in transit. So even if you happen to get into our network and you're looking at traffic, it's all encrypted in transit. Everything is only talking to what it should over HTTPS, and then TLS, which is an encryption layer of it tends to work underneath HTTPS. Like HTTPS establishes the connection. It establishes what we call non-repudiation. So we know who we're talking to, and they can't deny that it was them later. And then TLS forms a symmetric key encryption where we can then talk over symmetric keys. Now, some of you are very astute, probably all of you, and some of you have been around before when I've talked about this. If all of this is done in an asymmetric fashion, the key is asymmetric. It's a public and private cert, right, key pair. Why then, if that's asymmetric and that's what's required, why do we then move down to symmetric keying for the TLS communication? So that's the thing to think about. I've talked about it before, so some of you will be like, "Yeah, you just talked about this last night. I already know all that stuff." All right, well, I guess you know it. I guess I taught you something. I'll go to sleep a little. I'll feel better tonight. All right. So here's the shared responsibility model. This comes directly from AWS. There's the customer part and there's the AWS part. They're going to be responsible for their regions, their availability zones, their edge locations. Why speed? Excuse me. What did I say with speed? Cuddlingus, you got to help me out. Oh, yeah. It is speed. It is. Yeah. It's the cost of encrypting data. When you and when I say cost, I don't mean like money, like you're burning money. Although at some point you are, because there's an opportunity cost of doing something else with your servers that are then doing TLS work instead. But yeah, it's there's speed, and it's also that it's 1/10. It's approximately 1/10 the encryption cost to your system. When I say that again, I mean processing cost, which does eventually feed back into money eventually of encrypting. It's about 1/10 to do symmetric encryption instead of asymmetric encryption, and so it's faster and it's less costly. Tyler A said, "What is your streaming schedule?" Tyler, I try to stream a couple times a week. On Fridays, I stream a little earlier, and then Sundays we do labs all day. But I try to get a couple of times in a week, so I'm kind of just on hanging out for the most part. So I don't really adhere to my schedule probably as much as I should, but I try to get on, Monday. What is it? Monday, Tuesday, and Friday right now, because Wednesday and Thursdays I'm teaching college classes. So yeah, ICQ. I'm on YouTube. Yeah, I'm doing. Yeah, it's weird. Sometimes YouTube will have more people than Twitch, because like Twitch isn't really designed, like some of you guys know this, Twitch isn't really designed for like a learning platform. It's designed for people to watch gamers and, chuck bits at gamers and stuff. That's what the platform's designed for, and I think that's cool. But on the YouTube side, I think more people. I don't want to say you find more serious people. That's not the right way to say it. I think you find more people who are interested in learning things because YouTube is a place people go to learn stuff. 100%. All right, so defense in depth in the cloud, shared responsibility model. Again, you can turn all these things on, but if you choose not to, it's on you, right? All right. Another way to say this, the best way to say this, customers are responsible for security in the cloud, which is the data that you put in and the configuration of those systems. And AWS is going to do the clouds. They're going to keep the hardware up to date and operation of all the managed services and keep those things patched and that kind of stuff. What's going on over here? Let's see if the wife's messaged me yet. So when the wife messages me, that means she's coming home. It's 9:34. Jeez. Can't believe how late it is already. All right, we're gonna keep going. Kronk's Dev. Hopefully this stuff's useful to you. So cloud service providers. What are out there? This is from this blogs.vmware, which it's funny. I took this from there long before VMware was bought by Broadcom, but now VMware is changing greatly. Here's the product on the left. Here's the name over here. They are very, very, very interested in keeping the names different between like AWS and Microsoft Azure. I don't know if you guys have noticed that. They are very keen on nothing sounding too much the same. All right. So common issues in the cloud, right? The 4 common issues that people complain about. There's probably a bunch more, but there's a bunch of that I think they're actually, the cloud's here to solve these problems. But if you misconfigure, I mean, if you buy a you buy like a nice Lamborghini, you got some money, you buy yourself a nice Lamborghini, then you open up the back of that thing, because some of them do have engines in the front, some have engines in the back, but you open up that Lamborghini and you throw, you go to the Home Depot and you throw a big freezer in the back of it, and then you drive it home, and then you go drive it around like a dirt track for a little bit. That's not exactly what that thing was designed to do, is it? Could you do it? Absolutely. Most people are going to be looking at you like, what is this? Like, what are you doing here? This doesn't make any sense, right? And it's the same thing with the cloud. Like, you can do things in the cloud that are just a extension of bad things you're already doing. Yeah, it's your money. That's exactly right. You can do an extension of bad things up into the cloud whenever you want. Nobody's going to stop you. The cloud providers aren't going to stop you. They give you every opportunity to use the cloud the best way you can. I really do believe that. Like I've been through enough AWS certs, and I've been through enough AWS training, Azure for the most part too. They're like, look, don't do stupid stuff out here and get yourself a bunch of cost. They will train you. They will do all kinds of things for free. All that stuff's free. And then they'll do little calculators that'll show you exactly what things cost. I was pricing out the other day what it would cost to just run my own little Kubernetes cluster for some workload work for people. And I was like, this wouldn't be expensive at all. And even if I had multiple customers, it wouldn't even be expensive at all. And I just, price it out just for fun, and then when you're done with it, you can actually pull that pricing out and look at like what it would do, and then say, well, if I went to 5 times this big because I got as many customers as I expected, would I be able to do whatever? What if you just run a Kubernetes, like a test pipeline for people? You don't have to build your test pipeline anymore. You just drop your container over here and I'll do all your testing for it, and it'll just come out the other side good. That's pretty easy, right? That's a pretty easy little thing. Connectivity, latency, capacity, and security. These are things that people complain about all the time with the cloud. But these things are designed to be easier, right? So then, I think I cut this other thing out. But so connectivity, right? You're like, I need to have always on connectivity. The cost of this API is quite special to calculate. Yeah. I don't know. So I know that the look at here. We'll just pull it up real quick for some of you guys, because some of you guys are probably like, well, that's cool. What do I want to do in AWS cost calculator? Right here. I spelled it wrong and it still found it for me. I pop this little bad boy up and I go, all right, what do we want to do? Do we want to have, like, let's say we got a little company. So we're going to be, I'm always in US West 2. Like I'm always in Oregon, so I think that's why it shows up. And let's say we need an S3 bucket because we're going to store pictures that grandmas have of their kids or something. I don't know, whatever, right? And so simple S3 storage. We're going to do maybe S3 standard, but we'll probably do intelligent tiering because we don't know how much people are going to access this. And because we don't know that, we might want to start out with intelligent tiering so it moves the data for us. And then maybe one of the things that we offer, right? One of the things that we offer is you will never lose this data, but you will always have to pay us a subscription fee to have that or whatever, right? So we have this Glacier Deep archive, so we can save it for like 1/10 the cost of even being up here where people can access it, right? And you just have this basic little thing, and you're like, all right. So then you go do some calculations and you say, how much standard storage of gigs per month do we think we have? Well, we'll start out with we're probably gonna, we got 100 grannies that want to buy this service from us, so we're gonna start with 100 grand for the first month. I don't know. And there's gonna be how many put, copy, and list requests each month. Let's say that we've calculated that out to be like 5,000, right? And then people pulling that up to show their family and stuff is going to be like, let's say like 15,000, right? And then data return. So people coming back and looking at the data, and we might say that's 20 gigs per month, and then data scanned. Are we going to be scanning any of this data? Yeah, maybe we offer a service so that grannies can get whatever pictures they have of their cats and their grandkids and stuff, and we automatically move it into its own, we meta tag it, and then we move it into its own folders. So when they come in, they automatically go to all their grandkids in one place, and then all their pictures of cats. And even if they're in the same one, they're just showing in both different places, right? Something like that. So anyways, so here's the calculations of that cost. It's nothing. Like, I mean, not nothing. I mean, it's $2 a month or whatever. But if I even thought I was going to start that high, right? How are you going to find that many grannies? Now we go look for intelligent tiering and we say how much we're going to move around. Sure. And then we save and we add the service. So then we say we need an Amazon. So let's say Lambda, right? So we're going to use Lambda, and Lambda is going to be stuck behind an API gateway. So we're going to get some API gateway here in a second. But our architecture is going to be x86. We could use ARM if we had ARM code we needed. And how many requests per month? So we said that we were going to have about 5,000 pictures uploaded, but we're going to be doing a little more Lambda than that. So let's say maybe we're doing about 50,000 Lambda requests per month to handle all that. And the duration of each in milliseconds is, let's say 500, 500 milliseconds. And then the amount of memory allocated is actually based on the, when you do the memory, it's going to up your CPU usage. But let's say that we do about, in megs, it's about 512 megs. All right, boom. Oh, let's say it's a gig, So 1, and then we switch this down to gig. And that right there, starting out, would cost us nothing still. But then we could have provisioned concurrency, so we know that we have a certain amount of grannies doing stuff at 1 p.m. in the afternoon, because everybody knows that's when grannies get together and share their stuff the most, their pictures of their grandkids. I don't know. You might think like, oh, Scott, you're just saying absurd things. I do say a lot of absurd things. But did you guys know that as a network engineer, it was always right after lunch that people would come back and start really taxing the internet? I used to run I ran the firewall and wireless for a school district that had 36 different sites. I think they're up to like 40 something now. But when I first started my career, that's one of the things I did. And seriously, people really do come back from lunch and watch cat videos and bullshit on the internet. That's a huge thing. That's a real thing, right? That's not just me messing around. And then, okay, so we save them, we add that service. Now let's go put a gateway in front, an API gateway in front of that. So, right, so we're going to give them a way to go look at whatever's coming in. And our region, right, we want to pick the right region. But we're probably going to have a CloudFront in front of all this anyways. But Let's say that we're gonna get, I don't know, let's just say we get 1,000,000 API requests a month. That's fine. And then enter number of HTTP API requests in units selected. So let's say there's 1,000,000 API requests a month. That will cost us $1. And you say, well, what if I scope this all out and then I only have half that many million requests? I only have 500,000. Doesn't cost you $1 then. It only costs 50 cents. That's that measured service and what we were talking about in that in the talk earlier, right? So REST APIs, select the number, unit, and frequency for REST APIs based on expected volume. Calculations show calculations below exclude free tier discounts. So if you're doing it for the first year, you get all these free tier discounts. Let's say you're going to get, let's just say you get 2 million. All right, 2 million would cost you $8 a month. If you had 2 million API requests against the REST API for the grannies looking at their kids' pictures, right? WebSocket. Now, WebSocket is only if there's going to be like some control back and forth between these devices. I claim no great expertise in programming, but I understand what WebSockets are, right? And if I don't expect any WebSocket type transactions here, I can just put this down to nothing, right? And then there's our calculations. For WebSockets, nothing. For this, $7 if you get that high. And then we say save and add service. And when we're done, we're spending about $10 a month right now to prototype out our little, our little granny app or whatever, right? And then you go and you start to do your code and you start to build, you should probably draw some stuff out, like sketch up how you're going to get the data in and how are you going to authenticate your users. So maybe you're doing something like Cognito. Cognito will do what's called federated access for you. So federated access is this idea that you're going to allow people to just sign up by hitting, yeah, I'm from Google, right? Google, and then it just uses your Google federated access. You're already inside the federation of Google, and then Google allows you in. And federation means a bunch of people working together, right? That's what a federation is. Some of you probably know that from Star Trek, right? And I say percent of my monthly users who sign up through SAML or OIDC Federation. So let's say that we know these grannies are hip. They're hip to the Google, right? They're hip to the Google. So we think like 50% of them are coming in through Google. And what's our number of monthly active users? We hope to hit 5,000, right? And if we have 5,000 users, we would be spending, and we're charging them a little bit, right? We're charging them something. We would be at that. But let's say we only get 50 our first month. 50 users, that's $250. What if we're charging each user $250, right? Could we, if each user per month is paying $2.50 to see their grandkids all they want, could we still have a viable business? Yeah. Right? And then if it's scaled up, right? If we went back to that and we said it's scaled up, we could do that. So this is like, I'm just messing around here, but the point is, like, you guys could do all this. Yeah, the chat didn't know. Oh my gosh, the chat had no idea. It thought I was herding cats, like hurting them, not herding. Microsoft and their 5Gs and I'm just kidding. I don't know. All right. So what is our review? What is cloud computing? You guys should know what that is. What are the cloud deployment models? What does it mean to be a cloud service model? And what are our security concerns? What are service provider issues? And then what are some common issues in cloud environments? We talked about all those things, right? Boom. All right. Yeah, that was this intro to cloud computing. I don't have, let me see if I have another one open. I don't know if I have, no, I just have that one. Also, Treasure did this for us. That's a pretty nice little, don't you guys think that's a nice little, I think that's a pretty nice little, some of these are pretty cool. I think some of these look pretty nice. Personal intro. Anyways, those are going to be, I'm going to use this color scheme. I'll keep it with the blue probably. I'm going to use this color scheme, probably this one. I like this one more, with the Linux Systems Administration course. So I'll use this. So, all right. How's Ranger doing? That's how I feel right now, so I should probably get off of here soon. But if you like this stuff, you guys are welcome to go hang out down in Discord. we can hang out down there and do whatever. I'm going to be working on the course the rest of this week. I got to teach tomorrow night and the next night. And then I have date nights Friday nights. Date nights always Friday nights. And then date night with the wife, by the way, in case anybody's wondering. Then what else are we doing? Oh, yeah, Linux System Administration on Saturday. We're going to start a 16-week course on getting you guys ready to be systems administrators, right? That's down Discord. That's free. I don't charge anything in Discord because I think Discord should be a place where you guys can hang out, talk with other engineers, find things that are interesting to you and go work on them, right? Like, one of my favorite things that's happened in the Discord in all the 5 years that we've been running it is the other day when Salty started that little cove. And he started that, I think, a month ago or so, and people show up to it, right? It's pretty popular. So there you go. Okay. And Uzochi, I'll check it out when I get off of here. But yeah, I will see you guys. Let's go find somebody to raid. What's going on out in the world? Who is raidable right now? Who am I following that I can raid? We can raid over to... Let's go see if we can find somebody in the same category. Yeah, I can't find anybody. Here's what we're gonna do, guys. I'm just gonna call it all off. We'll just call it all off, and I will see you guys. DJ Black, I don't know what it is CE time. Saturday. I'm not 100% sure. I know what it is Phoenix time. It's actually I don't know what it is Phoenix time. I lied. Hold on, I gotta go check. Phoenix time is 3 p.m. So it'll be 3 p.m. my time, and that's Phoenix, which is about Mountain Standard time. So if you're down the Discord, just go look on the stuff, and it'll pop up for you guys. All right. Well, I guess we'll just call it here. We won't go rating.